Hello, everybody. Hello. Good evening, everybody. Am I audible, visible? Please let me know. Hi, da. Good evening, Rita. Yes, Madhumita, Jia, Elma. Yes. Pravina. Divya, right? Jason. Sushmita. Yes or no? I'm good. Yes. Hi. Guys, first வந்து like பண்ணிக்கோ everybody. Good evening. Ojal. Yes, Pravina is Ojal. I am Divya. Oh my god, completely confused actually. Hey guys, you just come with your own name, yeah. I can't remember this thing. Okay, and after that I am saying okay, physics la ella formulas வந்து you have to by heart. அந்த மாதிரி I will also say. Hi Ashika. Yes Tania. Yes Abhinaya. Yes, good evening. So, what da நம்ம first process என்ன? First process என்ன? Definitely நம்ம students, okay, நம்ம Re-NEET Tamil Naduல யாராச்சு new came. Yes. Now I'll remember. So, in the beginning onwards, you can just mention da. Okay. Yes. Today I joined earlier. Very good. So, என்னடா நம்ம first step என்ன? நம்ம free Re-NEET crash course வந்து introduce பண்ணணும்ல. Many students were struggling in the last few days வந்து அவ்ளோ important and right now நீங்க பார்த்தேன்னா நம்ம description boxல right now there is no much what to say links. Okay, you can see here நம்ம second link பார்த்தேன்னா நம்ம free Re-NEET crash course தான். Okay, you can see here da zero price க்கு தான் actually வந்து 4999 ஓட course வந்து we are going to give it for zero price. And you will be taking 1 minute to join, okay, to get this batch. So in the crash course you can see physics, chemistry, biology classes will be there, and you can see the test as well. Okay, and also here you can see the doubt solving 24/7 doubt solving, which is very important. Okay, which is very important. Okay, ஏனா வந்து we will study. Okay, இப்போ வந்து I mean all students cannot study on the same time, correct? Okay, everyone should wake up early in the morning 5 o'clock you have to start அந்த மாதிரி சொல்ல முடியாது, கரெக்ட் இல்லடா? ஏனா வந்து many students will stay at night, many students will go for sleep immediately. Okay, so அந்த மாதிரி டிஃபரெண்டான ஸ்டூடெண்ட்ஸ் இருக்கு. ஸோ ஒவ்வொரு டைம்லுமே யூ ஷுட் மேக் ஷுர், ஓகே, எனக்கு வந்து டவுட்ஸ் இருந்தா how I'll resolve. ஸோ அதுக்காக you can just go for this 24/7 doubt solving da. And yes, two more conchusa. Hey conchus. Okay, so right now you can see here another one, the register for Tamil Nadu's biggest Re-NEET mock test. So அதுக்காக அந்த லிங்க்ல கிளிக் பண்ணிக்கோ. You will be getting a sheet. Okay, so இந்த ஒரு sheet பார்த்தேனா நம்ம அஸ்வதி மேம் is already coming to this mock test. Okay, so definitely you can give your name, your phone number and your preferred location. So definitely that mock test is going to happen for you people. So 13th June க்கு தான், ஓகேவா? 13th June க்கு தான் actually வந்து நம்ம mock test. So time வந்து exactly நம்ம NEET ஓட time தான் 2 to 5 வரைக்கும் இந்த எக்ஸாம் இருக்கும். So you can also go for it. ஏனா வந்து நம்ம வேதாந்தோ is all spreaded all over in Tamil Nadu. You can see many centers இருக்குடா. So you can just go for your preferred location. You can see here. Okay, you can see here, you can just give your preferred location. இப்போ வந்து many students are coming from Tirunelveli, so you can just go for Tirunelveli. And 13th க்கு வந்து you can just write the mock test with many people. Okay, many people. Okay, it is always become competitive when there are more students. Okay, so pan India நம்ம வேதாந்தூல the mock test is happening and you will be getting the result as well. So don't miss this chance da. And also இன்னைக்கு வந்து what we are going to do, tell me everybody, what we have planned for today. இன்னைக்கு பிளான் என்னடா? ஏதாச்சும் பிளான் இருக்கா? நோ மேம், அப்படியே ஜோலியா இன்னைக்கு இந்த செஷன் ஸ்டார்ட் ஆச்சு, அப்படியே எண்ட் பண்ணலாம் மேம். சோ அந்த மாதிரியாடா? tell me many people are missing. ஆமாடா, இன்னைக்கு வந்து many classes எல்லாமே வந்து கான்செப்ட் ரிவிஷனா இருந்துச்சுல்ல, எக்ஸாஸ்டடா ஃபீல் பண்ணியிருக்க மாதிரி இருக்கு. Yes, I too miss many students. Hi Hajar. டஃபா இருக்கணும் அப்படின்னா எக்ஸாம் வந்து டஃப் ஆக போறேன்டா. சோ क्वेश्चंस வந்து அவ்வளவு டஃபா இருக்கணும்ல. எஸ் அஷிகா, கம்ப்ளீட் பிசிக்ஸ் நம்ம பார்ட் 2 தான், ஓகேவா? எஸ் guys, let us convert potential lights into kinetic eyes. Oh my god, Jia, you are very much creative, I should say this. Yes, what we are going to do, ma'am? Elma, very good. Okay, thumbnail பார்க்கவே இல்லடா. Okay, tough exam. ஆமாடா, கொஞ்சம் டஃபா இருக்கு, ஆனா அவ்வளவு டஃப் ஆகாது, பரவாயில்ல. ஹாய் தனு, நமஸ்தே. Welcome to the class. And guys, Marakama like panda. Optics. That is what I want. Optics on the start panlama. Okay. So we are going to start with the optics part. Okay. So ready? Ready now? Put some fire in the chat box quickly. Everybody. So in a session, we will finish it in 2 hours. I'm going to finish in 2 hours. Okay. So right now, நம்ம volume 2 complete we are going to cover in 2 hours. If you wanted to get the volume 1 na, அதோட link நம்ம chat box ல இருக்கு. Part 1 ஓட link நம்ம chat box ல இருக்கு. So you can just click on that and you can just go for it. Yes, so here we go. I am getting some energy. Okay, on the fire and the heat energy I got some energy. Now I am in the excited state. So let us go for the optics first. So first one, the optics what we have first one, I'm going to introduce one thing, nothing but laws of reflection. Can you please let me know, ma'am? You're okay, ma'am. Week quiz இன்னைக்கு week quiz இருந்துச்சுனா இந்த time extend ஆக போறோம். So let me think about it. Okay, in between I will get some kind of where is Srimukhi? Where is Srimukhi? I need her help. Okay, so yes, week quiz we can just discuss later. Okay, now you just listen here. Now week quiz veda in the concept finish pannanomla adum innum konjam time illa. So that is what our focus. Okay, yes, thermal energy of photon overloaded. Thermal energy of phone is overloaded. Amada enake theriyum morning onwards classes da, but definitely in the last 12 days and the phone madri you should also get some more heat energy and you should work like that. Then only nama 21st exam kapram around 5:15 5:30 when you people are coming around, your parents were waiting outside and they were very happy and you're running and you're just hugging your parents. Oh my god, what a moment. Yeah, what a moment. Yes, exactly Divya. Yes. So right now optics first one the nama laws of reflection da. Can you please give me the equations, everybody, quicker? Laws of reflection. Definitely nama incident ray, reflected ray. Oh my god, Elma. Oh my god, so much of effort. Okay, incident ray, reflected ray and the normal are in the same plane. And second one nama angle of incidence which is equal to angle of reflection. Next nama deviation or equation da. Do you remember the equation for deviation? Deviation na enna? Actually we know that this is the plane surface and right now this is the normal and right now there is a incident light over here. So this is what the incident angle and definitely with the same angle it will reflect back. So I will be equal to R da. So right now you can see that this has to go in the straight line, but what happened? It was going like this. So this is what the deviation. This is what the deviation. And what is the expression for this deviation? It is nothing but 180 minus 2i. So this is what the first thing. Now tell me now, what is the normal incidence? Can you give me the expression for normal incidence quicker? Tell me what is normal incidence? Normal incidence na, ma'am, very simple. So the light will fall through the normal. Okay, so exactly perpendicular to the surface it will fall. After reflection, what will happen da? What will happen? It will go along the same direction. Yena according to laws of reflection, incident angle should be equal to the reflected angle. Purinjidada, everybody? Can you give me a white forest in the chat box quickly? Everybody. Yes, Kavi, very good. Ashika, very good. Elma, very good. Let me just refresh again. Because yena chats ellame late da irukke. Guys, smash the like button, guys. Thank you, Rida. Thank you. Yes, we are going for perfect. Yes, perfect. So right now we can see normal incidence na nama incident angle 90 degree, reflected angle kuda it will be coming as 90 degree. Next one nama grazing incidence da. Okay ba? Nama grazing incidence da. What is grazing incidence? Can you please let me know? What is grazing incidence? It is nothing but idha nama normal. So the light will be, sorry, in the case incident angle 0 degree da. Okay, incident angle 0 degree. I have made a wrong statement. So normal incidence na ennada, it is actually making 0 degree with the normal, which means incident angle will be 0, reflected angle will be 0. Done, everybody? Everybody? So நம்ம grazing incident சொல்லும் போது it is along the surface da. So what is the incident angle? 90 degree. And what is the reflected angle? That is also 90 degree. If it has to be 90 degree, it should also go with the surface. So this is what the thing for the grazing incidents. Understood everybody? Can you give me a yellow forest in the chat box everybody? Quicker, can you give me a yellow forest? Everybody quickly. So next வந்து நம்ம plane mirror தான். Okay, plane mirror சொல்லும்போது அதுல வந்து நம்ம focal length. Okay, first வந்து I should talk about the focal length. Focal length வந்து infinity ஆ இருக்கும். And focal length and the radius of curvature க்கு one relation இருக்கு இல்லடா. What is that relation? R and F. R is nothing but 2 times F தான். Correct? R is nothing but 2 times F da. So definitely if F is infinity, what will be the R? R will also going to be infinity. And also plane mirror na. Okay, when I'm talking about plane mirror na, the image distance, okay, the image distance and the, sorry, this is the object. So object distance and the image distance will be always going to be same. Correct, Ada? And also I can say that the size of the object and the size of the image will be same. Appadina, can you give me an expression for the magnification of plane mirror? Can you give me the expression for magnification of the plane mirror? Everybody quickly, can you give me the expression for this magnification? Magnification will be nothing but, okay, it is nothing but the 1. Magnification in the case of what to say, nama plane mirror vanda, it will be coming as 1. So that also you should understand. Okay, and also எப்பவுமே நம்ம plane mirrorல கிடைக்க வேண்டிய, okay, we will be getting the erect and the virtual image da. Always plane mirrorல we will get the erect and the virtual image da. And also we have studied about the lateral inversion. Correct? We have studied about the lateral inversion. What is lateral inversion? We know that when I'm just raising the hand, right hand, I will feel in the image, I will feel like I'm raising the left hand. This is what the lateral inversion, which is a kind of property in the plane mirror. Next one enna, okay, next one enna innu interesting ah irukke, which means எனக்கு வந்து, okay, I wanted to see, okay, இப்போ வந்து இதுதான் வந்து ஒரு பென் இருக்கு. Let us say இதோட length வந்து 15 centimeter தான். Correct? Okay, we will be going for the what is a 15 centimeter da actually வந்து நம்ம what is in the pen ஓட length. Got it? இப்போ வந்து we know market la we will be getting different types of mirrors. Okay, I mean we will be getting very small mirrors to the bigger mirrors, right? Okay, correct? So அப்படினா நம்ம விட bigger ஆன mirrors வந்து it is possible. Okay, இது வந்து marketல available ஆ இருக்கு. So right now my question is very simple. எனக்கு வந்து இந்த ஒரு what to say, இந்த ஒரு pen வந்து கரெக்ட்டா அந்த mirrorல full image கிடைக்கணும். Okay, if I need to get the full image of this object, okay va, just listen. If I need to get the full image, okay, full image of the object, so what must be the mirror order size? Okay, nama mirror order size enna irukanum? Very simple, the total height of the object illada, total height of the object divided by 2 பண்ணிட்டேனா definitely you are going to get the full image. Understood everybody? Yes, very good Tanu. H by 2. What is H? நம்ம object oda height da. Understood? Can you give me a blue forest in the chat box quickly? Everybody please quick. Oh my god, in 10 minutes my energy got drained. Oh my god. Okay, yes. So right now this is what the another thing. Next one is nothing but regarding the number of images. Okay, number of images formed. Okay, so let us say I have 2 plane mirrors. Okay, what I have 2 plane mirrors. In the 2 plane mirrors, if I am placing at an angle, okay, if I am placing at an angle, I don't know the angle. Sorry, I know the angle, and the angle வந்து theta da. So tell me da, what is theta? Tell me da, what is theta? What is theta? Theta வந்து nothing but the angle between the 2 plane mirrors. Correct? அப்படினா number of images தான் வந்து நாம வந்து find பண்ணணும். So definitely I can just go for 360 divided by theta. Okay, so இப்போ வந்து இந்த வேல்யூல 360 by theta கிடைச்சேனா maybe you will be getting a odd number. Okay வா? Odd number, or you will be getting even number. Understood? இப்போ வந்து number of images தான். 2 plane mirrors இருக்கு. அதுக்குள்ள இருக்கிற angle வந்து nothing but நம்ம theta தான். அப்படினா I will be going for 360 minus theta. Okay, 360 minus theta. இதுதான் வந்து நம்ம plane mirror. This is what the angle. Okay, so right now you will be going for 360 by theta. இந்த 360 by theta பண்ணும்போது you will be getting two values. Okay, you can get either it is going to be odd. Okay, like 5, 7 or something, or you will be getting even. If it is even, never mind, the number of images always going to be 360 by theta minus 1. Okay va? 360 by theta minus 1. இப்போ வந்து odd number ஆச்சுனா, okay, odd number ஆச்சுனா, there is a problem. There is a problem. So this object can be symmetric or asymmetric, which means, just understand, okay. Yes, Ilma. That is why theta angle is coming. No. Okay, so right now we will be getting an odd number. In the odd number kadachena, first one you should check the position of the object. In the object one, it is actually at the angle bisector. I mean, otherwise not at the angle of bisector. Bisector irundiruchina same as here, 360 by theta minus 1 will be the number of images. If it is not in the bisector, then the number of images will be 360 by theta. Understood everybody? Yes or no? Yes or no? Can you please let me know? So number of images that we have discussed, adila vandu we just need to do 360 by theta. Okay va? So இப்போ வந்து இந்த 360 by theta பண்ணும்போது maybe you will be getting a odd number, இல்லனா you will be getting a even number. Correct? You will be getting a odd number or you will be getting a even number. Even number na there is no confusion whether it is at the angle bisector, which means let us say இதுதான் வந்து angle bisector. Okay, இப்போ வந்து நம்ம object is at the angle bisector or not, never mind, the number of images will be this one. Got it, yes or no? Got it, yes or no? Yes, exactly, Kavi. இப்போ வந்து bisector na we will say symmetric. இப்போ வந்து அந்த what is it is not at the bisector. Let us say நம்ம object வந்து இங்க தான் இருக்கு. Okay, நம்ம object வந்து இங்க தான் இருக்கு. So it is actually asymmetric. Asymmetric வரும்போது if it is odd only, நம்ம 360 by theta வந்து odd ஆன மட்டும்தான் it will be going for this one, 360 by theta. If it is asymmetric. Understood? Can you give me a red velvet in the chat box, guys? Everybody, please, quicka, can you give me a red forest? Everybody, and guys, marakama like panikoda, nama like ku target irukku. நம்ம லைட்டுக்கு வந்து டார்கெட் லைக்குக்கு வந்து டார்கெட் இருக்கு. I'm studying, I'm teaching this optics and always it is coming optics light. Okay, so லைக்குக்கு டார்கெட் இருக்கு, மறக்காம லைக் பண்ணிக்கோ. Everyone should like. Okay, I will check here as well. Let me just check how many of you have already liked, how many of you are still pending. Many more confused, many more confused. I hate this kind of confuse. I did not set any target. And my target வந்து என் ஸ்டூடெண்ட்ஸுக்கு வந்து 2 hours இது வந்து ஃபினிஷ் பண்ணணும். ஓகே, பிஃபோர் ட்ரெயினிங் மை எனர்ஜி. ஏன்னா வந்து மார்னிங் ஆன்வர்ட்ஸ் கிளாஸஸ் இருந்துருச்சு. ஸோ எனர்ஜி வந்து இட் இஸ் ஆக்சுவலி கோயிங் டவுன். பட் ஆனால் வந்து இந்த ரெட் வெல்வெட் எல்லாமே பார்க்கும்போது ஓகே ஐ வில் கெட் மோர் ஸ்வீட் அந்த மாதிரி இருக்கு. Okay, many more confused. Yes, I don't know why these people are doing like this. So next one, the velocity of image. Okay, velocity of image. So right now, just focus over here. Okay, just focus over here. Okay. So inga vandu nama mirror irukke. Okay, inga vandu nama mirror irukke. So in the mirror vandu at rest la da. Okay, first condition enna mirror vandu rest la da. So nama object vandu it is moving with a velocity. What is the velocity of image? Which means just imagine இப்போ வந்து உங்க முன்னாடி ஒரு mirror இருக்கு. You are just running with a velocity. Okay, what is going to be the velocity of the mirror? Quick, tell me. Quick. ஆமா, confuse. Get out of the class. Thank you, Madhumita. Okay, அவங்க வந்து disclick பண்ணி போண்டா. அதுதான் வந்து attitude. Yes, ma'am has energy because of us. Exactly, Hajir. Exactly. நீங்க தான் வந்து என் எனர்ஜி. Okay, இன்னைக்கு வந்து I was thought like okay இந்த செஷன் வந்து I need to எனக்கு வந்து இந்த செஷனுக்கு எனர்ஜியே இல்ல. When it comes to 6 o'clock I was like oh my god, but now I'm getting energy. It's only because of this. Yes, yes, very good, Tanu, very good. இதுக்கு கூட same velocity தான். ஆனா வந்து sign கொஞ்சம் different தான். Okay, ஏன்னா வந்து it will be going in the opposite direction. Correct? If you are running here, in the mirror பார்க்கும்போது it is coming towards you, right? So definitely it will be coming as minus v. Image ஓட speed வந்து it will be nothing but minus v தான். If object ஓட speed வந்து v. Understood? Now, can you give me a black forest in the chat box quickly? இப்போ வந்து another thing. Okay, இப்போ வந்து another thing, which means இப்போ வந்து this mirror is, okay, the mirror is actually moving vertically. Okay, it is actually moving vertically. Vertically in the sense, it is moving like this. Okay, it is moving like this. அப்படினா, will it happen? Will it affect our velocity? Never ever. Try to understand, when the mirror is vertically moving na, நம்ம velocity ல வந்து change கிடையாது. So the horizontal component, the vertical component will be remain same. நம்ம object ஓட same speed da it is going to. Okay, whatever be the object ஓட speed, that will be same in the case of vertically moving mirror. Got it, everybody? Guys, மறக்காம like பண்ணுடா and also subscribe the channel. ஏனா வந்து நம்ம சேனல்ல we are going to plan a lot of things in the upcoming days. Do not miss any of the things. Okay, so now our vertical part is also done. Now the interesting part. Okay, we need some kind of complicated situations, right? Very good. No change in velocity when the mirror is actually moving in the vertical directions. Okay, if it is moving in the vertical direction. Now here is the problem. So nama mirror is actually moving in a random direction. Okay, பரவாயில்ல, very simple. First வந்து you will find the x component of mirror and y component of mirror. ஓகேவா? So இப்போ வந்து பார்த்தேனா நம்ம object ஓட velocity வந்து v தான். Okay, vo, and நம்ம image ஓட velocity வந்து let us say vi. Correct? So let us say, I'm just assuming one more thing. This is also moving in a random direction. Okay, now our object is also moving in a random direction. So all the problems is sorted. So this is what our x component, this is what our y component. Understood the scenario, everybody? Please let me know. Understood the scenario, everybody? So actually the mirror is also moving with a velocity vm, and also nama object is also moving with the velocity in a random direction. அப்படினா நம்ம image ஓட, okay, இதுதான் வந்து நம்ம image. Okay, so image வந்து பார்க்கும்போது again நம்ம velocity vertical component ல change எதுவும் இருக்காது. It will be remains the same. Okay, நம்ம object ஓட same velocity தான் for this image ஓட vertical velocity. Now when it comes to the x component, okay, அதுக்கு வந்து you can just use this equation da, very simple equation. Velocity of object with respect to mirror, which means nama relative velocity should be equal to the relative velocity of the image with respect to object. Understood? If it is moving in a random direction, if it is moving in a random direction, what we should use? We should use this expression VOM, which is equal to minus VIO. What is VOM? The velocity of object with respect to mirror. And what is VIO? The velocity of image with respect to, VM, with respect to mirror. Got it? Understood? Can you give me a red velvet in the chat box again? Everybody? Yes, exactly, Divya, exactly. Very good. So அப்படினா now my question is, if I am expanding this, I will be getting VO minus VM, which is equal to minus VI minus VM. So if I'm just multiplying this minus inside, so I'll be getting minus VI plus VM. Understood, Ada? Yes or no? Yes or no? இப்போ வந்து பார்த்தேனா இந்த ஒரு equationல இருந்து, what is the equation? VO minus VM, which is equal to minus VI plus VM. I wanted to find the velocity of the mirror. Okay, I wanted to find the velocity of the mirror in terms of velocity of object and the image. Can you give me the expression? In terms of velocity of object, in terms of velocity of image, we need the expression for velocity of the mirror. Yes, da. This is that case. It is actually object is also moving. What is it? Mirror is also moving. You can just use it everywhere. Yes, very good. So right now you can see here, we will be getting 2 Vm, which is equal to, we will be taking this over here. So we will be getting Vi. Sorry. Okay. So right now I'm just keeping this V. I wanted to find Vm, right? Okay. I'm sorry. Okay. I wanted to find Vm. So right now I can go for Vm will be Vo plus Vi divided by 2. It will. So if you need to find the image order velocity now, if you know the velocity of mirror, if you know the velocity of object, you can just find it. Understood, everybody? Yes or no? Give me a white forest again in the chat box quickly. Quickly give me a white forest, everybody. Perfect, perfect. So now again we are going for the spherical mirrors. So in the spherical mirror, first one the ray diagram da. So I'm not explaining this ray diagram and everything because you people are already pro in it, correct? So definitely I have given the where is the position of the image and the properties of the image ellame vande explain pannirukren. In the table vande I kept it over here and the diagrams are also here. So idukkaga in the diagram thukaga I will be just explaining the process. So let us say we have a mirror like this and here is the principal axis. Correct? Here is the principal axis. Yes, guys, smash the like button. Yes, guys, like the video. Conjuse. You are very slow, guys. Why, guys? Why you people are doing like this? Ippave vandu channel subscribe panniko. Also like the channel. So right now, what is this? What is this? Adu vandu pole. Now you can see here is the focus and 2f is r. So this is what the thing. And wherever be the object, okay, ipo vandu object inge irukku. So what we should do? First we will go for a parallel line. If a ray is parallel to the principal axis, my question is, if a ray is parallel to the principal axis, after reflection, it will passes through. After reflection, it will passes through the focus. Another one, you should understand. When, if it is, okay, இப்போ வந்து object இங்க இருக்கு, okay, so right now one ray is passes through the radius or let's say நம்ம center of curvature, okay, நம்ம center of curvature, if a ray is actually passing through the center of curvature, now what will happen? It will retrace its path, okay, it will retrace its path, which means it will just go that way and it will come back to that. Understood? Another one. Please give me the answer for this. Okay. So right now, one ray is actually passes through the focus. One ray is passes through the focus. Appadina what will happen? If it is passes through the focus, after reflection, it will be parallel to the principal axis. Very good. So appadina another case, if it is, okay, if it is, I'm just going for another one, otherwise it is going to be very difficult to understand. So right now one ray is coming from the object and it is making an angle I over here with the principal axis. After reflection, what will happen? It will again make the same angle. Yena inga vandu paathena, this is going to be the laws of reflection. Spherical mirrors la kuda in the laws of reflection vandu valid da. So what will happen? Incident ray will be falling over here and it is making an angle I with the principal axis. Definitely after reflection, it will go with the same angle. Understood, everybody? Yes or no? So these are the possible rays which is possible for the ray diagram. So you can choose any of this and you can go for the answer. Understood, everybody? Yes or no? Give your favorite heart in the chat box, everybody, quickly. Yes, very good. So நம்ம ரே டயக்ரத்துல இந்த லைன்ஸ் ஓட how the flow அது வந்து புரிஞ்சிடுச்சுனா you can do many questions. Okay, you can do many questions. And now the sign convention தான். So sign convention, how you will be finding the sign? So let us say இப்போ வந்து object வந்து இப்படி தான் இருக்கு. So அப்படினா நம்ம vertical distance, height of the object. What is going to be the height of the object? It is going to be positive or negative? Of course, ma'am, if it is above the horizontal line, vertical distance எல்லாமே வந்து it will become positive. If the image is like this, Appadina, what will happen? Image, if it is like this, what will happen? It will again become negative. When you are finding the vertical distances, if it is above the horizontal line, adu positive da. If it is below the line, it is going to be negative. Understood? Just give your favorite emoji, everybody quickly. So next nama horizontal distance calculate பண்ணும்போது note பண்ணிக்கோ, always when we are talking about the horizontal distance, okay, when we are talking about the horizontal distance when you're talking about the horizontal distance this will be always calculated from the pole. This will be always calculated from the pole da. Next one enna horizontal distance we will calculate from the pole, and always if it is okay, we will take in the direction of light. Ipo indha or case la paathena light is going in this way. In the light direction, it will become positive. If you are calculating anything in the opposite direction of light, if only the object distance pathena, it will become negative. Got it, everybody? Yes or no? Yes or no? So these are the things you have to notice in the case of while we are going for the ray diagram. Sign convention is also very important. We will be using the mirror formula to find the focus, or let's say we will be finding the image distance, and the time la idu avlo helpful ah irukum. Okay, very good Elma. Direction of light na positive da. If you are calculating in the opposite direction, it will become negative, and always it has to calculate from the pole. So now, okay, so now reflection of light ellame vandu discuss panniyacha. Okay, yes, here is the another one. So when we are talking about the mirror formula, okay, when we are talking about the mirror formula, we can say that 1 by u plus 1 by v, which is equal to 1 by f da, and here we have to substitute the sign convention as well. If it is a convex, concave mirror na, what is going to be the v value, what is going to be the u value, whether it is going to be positive, negative, you have to mention it over here. Next one nama magnification da. Magnification or equation it is nothing but minus v by u da, which is also we can say that height of the image divided by height of the object da. And whenever we are talking about nama magnification or a magnitude, okay, nama magnitude, again it's gone, okay, nama magnification or a magnitude if it is greater than 1, okay, if it is greater than 1, nama magnification or a magnitude greater than 1, what is the meaning? What is the meaning? Quickly let me know. Magnification more than 1 da. Then definitely I would like to say this is nothing but a enlarged image. Okay, it is nothing but the enlarged image. If I am talking about the magnification, which is nothing but 1, the magnitude of the magnification is 1. What is the meaning? What is the meaning? Magnification 1 na adoda meaning same size da. Okay va? It is nothing but the same size da. Now tell me da, if it is less than 1, magnification oda value less than 1 na, what is the meaning? Idu or diminished, okay, small da, comparing with the object, it is actually nama image it is actually coming as what to say nama diminished da. Now let us say nama magnification negative, which means less than 0. What it is indicating? What it is indicating? Magnification less than 0, which means if it is negative na, the thing is like nama image inverted da. Inverted na just ulta. Okay va? It is showing it is what to say inverted da. And also now it is the turn for when it is positive. Okay, when it is positive, which means greater than 0 sollumbodhu, I could say that this is nothing but, it is nothing but erect. Understood everybody? Everybody understood? Can you please let me know? Can you please let me know quickly? Yes, perfect. So now we are going for the refraction. Okay, refraction of the light da we are going for it. So nama refraction la first we should study the laws of refraction. What are the laws of refraction? Can you please let me know quickly? Can you please let me know quickly what is refraction? Refraction na, it is actually the bending of light da. Okay, when the light is moving from oru mediathila irundhu it is going to another medium na, definitely bending of light will happen, and the bending of light da actually 41 likes more. Guys, don't forget to like the session, ippave like pannikoda and subscribe the channel. Yes, appadina we can say that bending of light da nama refraction. And laws of refraction, can you please let me know? Can you please let me know? Laws of refraction sollumbodhu, I could say that definitely incident ray, refracted ray, normal are along the same plane. Also, another thing is nothing but sin I by sin R. Sin I by sin R, which is nothing but equal to nama refractive index. This is a constant value da, which is nothing but the refractive index. Understood? Can you give me a favorite, your favorite heart in the chat box, guys? Everybody, please. Everybody. Yes, exactly. So right now, if I'm writing like this, okay, sin I divided by sin R, mu I can write when the light is coming from a air, okay, in a vacuum. So right now I'm just specifying mu2 by mu1. So now I know the equation for refractive index. Do you guys remember the equation for refractive index? What is that equation? It is nothing but C by V da. Appadina I will go for C na the constant value da. So C by V2 divided by C by V1, which means it is nothing but V1 by V2, which means mu2 by mu1, which is equal to V1 by V2. Another one is velocity and wavelength order relation. Can you give me the equation, everybody? Velocity and wavelength order relation. Velocity is nothing but F lambda. Frequency na adu vandu source property da. Medium vandu change aanalum frequency vandu change agadu. So appadina when I'm going for V1 by V2, I could go for lambda 1 by lambda 2. Understood, everybody? Yes or no? So I can just go for this equation as well for the Snell's law. Okay, just study this whole equation. Depending upon the question, you can choose it and you can go for it. Got it? Yes, Rita, very good. F lambda, very good. Okay, so now we have one more, that is nothing but nama apparent depth. Apparent depth na definitely when we are just standing on the river, we can see that ground part, right? So but definitely nama parents ellarume they will say that don't jump, the depth will be more. Okay, what is the principle? Refractive index, correct? Refractive index. The light is coming from one medium to the another medium. Definitely, the bending of light will happen, and due to that, we will feel like, okay, due to that, what we will feel? We will feel like, okay, the depth is less. Okay, the apparent depth, the depth which we are feeling. Okay, and the apparent depth or expression vandu d na actual depth da into nama refractive index, rarer medium. So I'll write it over here again. So you just note it down. The depth, the real depth into the refractive index of the rarer medium to the denser medium. Understood, everybody? Yes or no? Yes, Brinta. Good evening. Good evening. Got it? Everybody? Yes or no? Please let me know. Guys, still you people are not liking the session, and I don't like that at all. Yes. Bubbly, we have already done this da. Nama 11th vandu finish ஆயிருக்கு. Part 1 vandu finish ஆயிருக்கு. Part 1 oda link vandu you can see it in the chat box la pin பண்ணிருக்கேன். So you can just watch it. இது வந்து நம்ம volume 2 da. Okay va? So now we are going for the lateral shift. Lateral shift na enna? Let us say இப்போ வந்து எனக்கு வந்து இங்க ஒரு glass slab இருக்கு. Okay, glass slab இருக்கு. அதோட thickness என்னடா? T da. So now what is happening? இது வந்து இந்த ஒரு surface ல இருக்கிற normal da. So the light will falls like this. Okay, we know that இது வந்து rarer medium da. இது வந்து denser medium da. இது வந்து again rarer medium da. So now tell me da, if the light is coming from the rarer medium to the denser medium, what will happen to the incident? I mean, what will happen to the refracted angle? Will it increase or decrease? Which means after this point, refraction, this ray will move away from the normal or come towards the normal. What will happen basically? It will definitely come towards the normal. So R will be, I could say that I will be greater than that of R because the light is coming from the rarer to the denser medium. Understood? Can you give me a white chart till this? Yes, bend towards the normal. Very good, very good, very good. Everybody, super, super. Okay, so right now we understood this. Again at this point, okay, again at this point, what will happen? What will happen? This is again R da. Now again denser to rarer medium da. So what will happen to the ray? Will it move away from the normal or come towards? Of course, denser to rarer na, it will go away from the normal. So this is going to be nama emergent angle. Right now, till this understood everybody? Yes or no? So actually வந்து பார்த்தேனா இப்போ வந்து இந்த refraction doesn't happen. Okay, refraction இங்க இல்ல. அப்படினா what will happen da? What will happen? This will go with this way. கரெக்ட்டா? இந்த incident ray வந்து இந்த incident ray வந்து it has to, oh my god, okay, it has to go in the same parallel, I mean இது வந்து it should go like this. அப்படினா you can see here the emergent ray and the incident ray, if there is no refraction happened, it will go like this, and these two lines will be parallel, and this is what the lateral shift. This is what the lateral shift. Understood everybody? And the lateral shift, if you need it now, you can just go for this equation. D will be equal to sine I minus R into the thickness of the slab divided by cos R. You can just use this equation. Understood everybody? Yes or no? Quick let me know. Quick let me know everybody. So this is what the expression for the lateral inversion. What is that, the bigger one with heart? Okay. So yes, can we go for the total internal reflection? Ready? Nama ray optics one inno finish agala. I was just planned for 30 minutes for this one. Formula sheet, yes Tanya, I will give it by tomorrow. Tomorrow I will just post a video. So on the video kulla I will be just mention all this PDF. Okay va? So dimension order for videos irukku, mind maps irukku, ellame irukku. I will just mention everything together in a single video. Naaleki vanda you can, today anyway I cannot record it. So naaleki vanda I will record and I will just paste all the PDF. Fine? Not visible ah? I have written noda, ade podu. Now is it fine? I hope it is readable format. Yes or no? Is it fine now? Correct. Okay. So now we are going for the total internal reflection. Now you people tell me, what is total internal reflection? Total internal reflection, adu vandu reflection. Oh my god, I'm feeling so dark. Let me just increase the brightness a little bit. Okay. I think I'm becoming even more darker. Oh my god. So hope it is fine right now. No. What about white background? Something was happened. Okay. So now, it's almost fine. Manageable. So right now we are going for the total internal reflection. Okay. So total internal reflection ennada. So guys, marakama channel subscribe pannika and also like the session. Okay, yes, the part 2 of the 12th part. Okay, and we will finish it like this. Okay, so now total internal reflection சொல்லும்போது when the light, okay, இப்போ வந்து இங்க ஒரு surface இருக்கு. Okay, இப்போ வந்து இங்க ஒரு surface இருக்கு. So இந்த surface பார்த்தேனா you can see here, this is the normal. So the light is actually falling from here. Okay, இது வந்து denser medium இருக்கணும், and this has to be rarer medium. One condition is there for the total internal reflection. It is nothing but the light has to travel from the denser to the rarer medium. Okay, so right now இப்போ வந்து இந்த incident angle I தான், it will be after refraction. இப்போ வந்து denser to rarer na, what will happen da? It will move away, correct? It will move away from it. So again, if I am increasing the angle, okay, again if I am increasing the incident angle, what will happen? At some point after refraction, it will pass us through the surface, which means this particular incident angle, I will be call it as the critical angle. So tell me, what is going to be the critical angle? Move away, yeah. Okay. I was thought like you people are saying move away. Okay. So right now, what is critical angle? Critical angle the angle of incidence. Okay, the angle of incidence when it is the angle of incidence at which the refracted angle become 90 degree. Okay, refracted angle become 90 degree. இப்போ வந்து the light is moving from denser to rarer and the angle of incidence is more than the critical angle, now it will reflect back to the same medium, which means again if we are increasing the angle, it will reflect back to the same medium. So I can say that this is what the total internal reflection. And in the total internal reflection, when you are studying this total internal reflection, you should study the equation for the critical angle as well. Okay, I know it is not visible, I will write it over here. So sine of this critical angle will be equal to mu2, or let's say mu2 by mu1, which means here in this case la nama second medium vandu nama rarer medium da. So refractive index of the rarer medium divided by the refractive index of the denser medium. Understood everybody? Don't forget to like the session and also marakama channel subscribe panniko. And if you understood till this, can you give me a red velvet in the chat box, everybody? 11th எல்லாமே வந்து முடிஞ்சிருக்கேடா நிலா, இது வந்து 12th மட்டும்தான். ஓகே, yes, perfect. So இதுதான் வந்து நம்ம total internal reflectionல இருக்கு, and you should study the equation for the critical angle as well. Now we are going for the refraction at the நம்ம spherical surface. அதுக்கு வந்து you have to study this equation, mu2 by v minus mu1 by u, which is equal to mu2 minus mu1 divided by r. Okay, so இப்போ வந்து we have a spherical surface na, we can just use this equation. இந்த ஒரு equation use பண்ணி தான் actually வந்து we have made the lens makers formula, which is very important. We can expect multiple times, okay, multiple times வந்து இந்த ஒரு equation choose பண்ணி they have asked the question. So guys, you have to study this. Lens makers formula na, it is nothing but 1 by f, which is equal to mu minus 1. இப்போ வந்து the light is coming from air na, we can just simply say mu minus 1 into 1 by r1 minus 1 by r2. இப்போ வந்து medium is different, air alla, some other medium na, you can go for mu of the lens. Okay, நம்ம lens oda refractive index divided by the refractive index of the medium minus 1. Understood ada everybody understood? Please let me know. Ma'am, I feel like I'm in zero. Will I able to score in physics? Just attend these sessions da, and adukapram practice more questions. So 0 la irundhu you can improve. I'm not telling you can become from 0 to 180 is not possible if you are feeling 0 right now. Ena vandu hardly 12 days da irukke. In the 12 days la we cannot do some miracle things. Okay, but definitely if you are just planning your days well for the upcoming days, you can just improve your score to 60 to 80. That is what I can tell you. Okay, so next வந்து நம்ம thin lens formula da. Thin lens formula is nothing but அங்க வந்து mirror formula na 1 by f, which is equal to 1 by v plus 1 by u. What is thin lens formula? 1 by f, which is equal to 1 by v minus 1 by u. And what is the lens order magnification? Do you remember the equation? This equation? Nama lens order magnification, it is nothing but just simply v by u. There is no minus sign. It is simply v by u mattunda irukke, which is equal to height of the image divided by height of the object. 33 likes more, guys. Don't forget to like the session. I know you people forget while you are just listening the class. Now I have given the reminder. So marakama, you can just subscribe and you can just like the session da. Don't forget. Okay, so this is what the thing we need to study in this case. And here we have again the lens order ray diagrams, exactly similar to the mirror, whatever we have discussed. Appadida we have to go for the diagrams for the lens as well. Inga vandu the position properties ellame vandu I have explained in a table, so you can just go for this as well. Magnification we have already discussed, hi by h, height of the image divided by height of the object, which is also equal to v by u. Next vandu நம்ம பவர் தான். ஓகே, லென்ஸோட பவர் தான், which will be very simple, 1 by f. ஆனா வந்து நம்ம focal length should be in meters ஆ இருக்கணும். ஓகே, 1 by f ஆ இருக்கணும். f னா அது வந்து மீட்டர்ல இருக்கணும். And the unit for the power of lens அது வந்து diopter தான். ஓகேவா? So study this. ஏன்னா வந்து 1 yearல they have asked this unit also. Okay, so don't miss even a very simple statement, very simple unit. Power order unit வந்து diopter da, or else you can go for meter inverse. Okay, ஏனா வந்து power என்ன 1 by f இல்லடா, so you can just go for meter inverse as well, but generally we will say diopter only. Got it, everybody? Can you give me a black forest quickly? Let me get some energy quickly. Okay, so next one, the combination of lenses da. Combination of lenses சொல்லும்போது நம்ம effective focal length will be coming as 1 by f1 plus 1 by f2 plus 1 by f3. 1 by f1 na enna, power of the first one, and 1 by f2 na enna, power of the second one, 1 by f3 na enna, power of the third one. So we can say that the power, the effective power will be p1 plus p2 plus p3. Guys, மறக்காம like பண்றா. Why you people are not liking the session? Why? What is the problem, guys? Let us go for prism. Let us go for prism. இது வந்து இன்னும் ஃபினிஷே ஆகலடா. 50 minutes ஆச்சு ray optics. Oh my god, I was expected in 30 minutes I will finish. ஆனா வந்து இது வந்து அவ்ளோ டிஃபிகல்ட்டா இருக்கு. So prism சொல்லும்போது we know that நம்ம prism வந்து இப்படி தான் இருக்கும். Okay, so this is what our prism looks like. And now what will happen da? Idu on the rarer medium. This is what the denser medium. This is again rarer medium. So this is the perpendicular over here. This is the perpendicular over here. Now let us just draw the incident ray is coming over here. This is what the incident angle. So rarer to denser medium. Will the ray go away or come closer? Come closer. Of course, ma'am, come closer. It will be towards the normal aricum. So first refraction is over. Okay, adukapram in the second surface la again there will be a refraction. So let me just say this is what r1, I will call this as r2. Okay, second surface oda incident angle vandu r2 da. Denser to rarer sollumbodhu what will happen? It will move away from it. So this is what the emergent angle. So this is what the diagram which we needed for the angle, which we needed for the prism. So angle A, this is what the angle of prism. This is what A. அப்படினா angle of prism first வந்து we should understand நம்ம angle of prism A will be equal to r1 plus r2. First one. Second one என்னன்னா deviation. நம்ம deviation என்னடா, we already discussed about it. கரெக்ட்டா? Deviation actually வந்து இந்த ray should go like this. correct அல்ல? இந்த ray should go like this. ஆனா வந்து after refraction it got deviated like this. அப்படினா இந்த emergent ray வந்து I will just extend back, and this is what our deviation. And the deviation, how we will be finding it da? I plus E, incident angle plus emergent angle minus angle of prism will be giving me the what? This delta. Understood, everybody? Yes or no? Gobika, definitely we will do da. We will do. Just wait for a few more days da. And also in the sessions ellame vandu already there in the channel. You start watching it. Live sessions will be after 21st. We also know, okay, many students are hoping what is a very big things. Of course it will come. And I want the konjam priority right now for the Re-NEET kids da. Sorry for right now. Okay, so yes. So now the thing is like minimum deviation da. Okay, எனக்கு வந்து I know இப்போ வந்து இந்த light ray எல்லாமே வந்து இந்த prismத்தோட two surfaceல வந்து when it comes to the two surfaces அங்க வந்து refraction இருக்கும், deviation இருக்கும். எனக்கு தெரியும் மேம். ஆனா வந்து எனக்கு minimum deviation தேவையா இருக்கு. என்னடா இதுக்கு minimum deviation எல்லாமே வந்து தேவையா இருக்கு. So அந்த minimum deviationக்கு இருக்கிற condition என்னன்னா incident angle and emergent angle should be the same. And also நம்ம refraction happened இல்லையாடா, நம்ம r1 and r2 இது வந்து it should be equal to a by 2 ஆ இருக்கணும். கரெக்ட்டா? Okay, what is the condition for minimum deviation? I should be equal to E, r1 should be equal to r2, and that has to be equal to a by 2. Condition is very, very, very important. Condition is very, very important. And also one more thing is there that first refracted ray illada in the ray, this has to be parallel with the base of the prism. Okay, it has to be parallel with the base of the prism. Understood, everybody? Can you give me a favorite heart? I need some energy, and the energy kaga can you give me some heart? Can you give me some love? Everybody, quicka. Let me drink some water as well. Okay, yes. Thank you, Ashika. Thank you. Okay, so now இப்போ வந்து பார்த்தேனா if you got the minimum deviation, okay, minimum deviation அப்படினா what will happen? What will happen? We need to find the refractive index of this prism. Correct? Refractive index of the prism na adoda equation என்னடா sin I by sin R da. Correct alla? Sin I by sin R da. So definitely when I'm talking about R, nama R1. What is R1? A by 2. So I will substitute for R, I will be substituted as A by 2. Now it is the turn for I. Take energy, ma'am. Thank you, Rida. Got some energy. Okay. So now it is a turn for I. What will be I? So let me just substitute over here. Okay. Delta na what we said? I plus E minus A da. So I plus E. We know the condition at the minimum deviation. Incident angle should be equal to the emergent angle. Appadina, can I write 2I minus A, which is equal to number minimum deviation? Yes or no? Quickly let me know let me know if you understood or what. So I'm just replacing I plus E as 2I because minimum deviation in the two values one the same da. So I can say that I plus I or I can say that E plus E. So I'll be getting this. I will be just finding the I value. Delta M plus A divided by 2 will be coming as I, and I will be substituting here I and R. Now I'll be getting the refractive index of this, what is it, nama prism, which will be coming as this equation. Understood? Can you give me a yellow heart quickly, everybody? I think I'm just giving, I'm taking more voice because I'm just very much conscious in the class when the minimum time la finish pannanomla. So maybe due to that I'm just feeling exhausted every time. So next on the thin prism da. What is thin prism? What is thin prism? Thin prism na mu minus 1 into A. What is A? What is A? A in a refractive index of the medium da. So ma'am, when we should, okay, ipo vandu idoda angle vandu 10 degree na, can we use it? No, never. இப்போ வந்து இந்த angle of, okay, angle of prism நம்ம A இல்லையாடா, இந்த A value if it is less than 5 degree, then you can go for this equation delta, which is equal to mu minus 1 into the angle of prism. Angle of prism. Understood everybody? Understood everybody? Next one என்னன்னா, okay, next one என்னன்னா நம்ம angular dispersion தான். Angular dispersion சொல்லும்போது we will represent it as theta, which is nothing but the deviation happened for the violet light minus the deviation happened for the red light, which means the extreme illada. Oh my god, thank you so much, Ra. Thank you so much. Okay, this is why I love these students. Okay, I just love them. Because you will, if I'm asking what is a little bit energy, people will make me to the higher excited level. Avlo energy you people will give. You people are my photons. Okay, you people are actually my photons. So now angular dispersion. Angular dispersion என்னடா, the deviation happened for the extreme lights, which means violet and the red, which means deviation for violet minus deviation for the red. So definitely I will be getting, இப்போ வந்து A into angle of prism is same. So இங்க வந்து mu V minus 1 minus A into mu R minus 1. So by doing that, you will be getting the expression as A into mu V minus mu R. Understood? Everybody? Yes or no? Yes or no? You deserve it, ma'am. Thank you, Divya. Thank you so much. Okay. So this is what the angular dispersion. Next one, the dispersive power. Dispersive power na angular dispersion divided by the deviation of mean color. What is our mean color? What is our mean color? Nama middle la irukra and the color, which means yellow. How we will be finding the deviation of yellow? Very simple. Deviation of yellow will be coming as deviation of violet plus deviation of red divided by 2. So if you are just doing angular dispersion divided by delta y, the deviation happened for the yellow light na, you will be getting the dispersive power, which will be coming as mu v minus mu r divided by mu y minus 1. These equations you guys have to study. There is no other, there is no shortcuts. You guys have to study. I hope it is clear. Correct? Guys, 25 more likes, guys. Be active in the like button also. Just check it whether it is working or what. Let us go for the optical instruments. Ready? Can we go for the optical instruments? Yes or no? Yes or no? Yes or no? Optical instruments, optical instruments. Ready? Elma is ready. 24 more, Ashiga. Yes. Guys, keep an eye on this likes. You didn't like the session. Now you can like. In the madri, yarume solla matenda. Now only, I'm reminding in every minute. Okay, perfect. So let us go for the optical instruments. Optical instruments சொல்லும்போது first வந்து நம்ம simple microscope இருக்கு, compound microscope இருக்கு. Okay, so இதுல வந்து the problem என்னன்னா we should find the magnification ஓட equation. Okay, whether it is simple microscope, compound microscope, astronomical telescope, the thing is like we need the I will repeat the no worries Hajar. Sorry, Mitra. Right, Mitra, don't worry. Okay, so right now magnification oda expression da actually vandu we need it in 3 cases la. Magnification சொல்லும்போது we can see the object at our least distinction. நம்ம capital D அதோட value என்ன 25 centimeter. Okay, actually vandu whenever you wanted to, if you are trying to read nalum, you should keep at 25 centimeter away to read it properly. adha vandu நம்ம least distinction. So image can form in the least distinction, or let's say it will be forming at the infinity. Okay, va? So magnification, for these 3 instruments we have to find it for the normal adjustment as well as the maximum strain, which means இது வந்து strain ஆ இருக்குல்ல, அவ்வளோ difficult ஆ இருக்குல்ல, ஆனா வந்து eye is not strained. Okay, which means அவ்வளோ stress இருக்காது when it is at the word I forgot when it is at infinity. Okay, when it is at infinity. So idha vandu actually we need to find it out. So magnification sollumbodhu, if it is okay for a simple microscope, magnification at the least distinction will be coming as 1 plus d by f. இப்போ வந்து if it is at infinity na adu வந்து normal adjustment. Okay, there is no stress for eye. நம்ம eyes வந்து stress இல்ல. Okay, so now yes, exactly, normal adjustment 25 centimeter and not strain for the infinity la irukkiradhu. Very good. So இப்போ வந்து least distinction lana நம்ம magnification oda expression வந்து 1 plus d by f da. Okay, இப்போ வந்து same simple microscope la we need to know if the image is at infinity, what is the going to be the magnification. Magnification will be very simple, d by f. Understood? Can you give me a white forest in the chat box quickly? Next one, biology live. I'm a new student. Hi, that is your name. Okay, நாளைக்கு இருக்கும்டா. Okay, so right now this is what the thing. Next one, the compound microscope da. Compound microscope, guys, don't forget to subscribe the channel and also மறக்காம like பண்ணிக்கோ, இப்பவே like பண்ணிக்கோ. Next one, the compound microscope. Compound microscope la very simple, magnification or equations எல்லாமே வந்து remember பண்றதுக்கு அவ்வளோ difficult மேம், என்னால முடியாது மேம். இது வந்து உன்னால முடியும்ல, இந்த 2 equations வந்து அவ்வளோ clear-ஆ you can just study, right? அப்படினா now coming to the compound microscope, magnification ஓட general formula. This is what the general formula, which means நம்ம objective ஓட magnification into நம்ம eyepiece ஓட magnification. Objective ஓட magnification வந்து it is same in what to say, நம்ம இது வந்து image வந்து least distinction la இல்லனா infinity la பரவாயில்லை, it is going to be same. What is that இது வந்து VO by UO da. Okay va? So நம்ம objective ஓட what is a magnification will be coming as the image distance of the objective divided by the object ஓட objective distance. Got it? So first part is over. Now ME, eyepiece oda magnification. அது வந்து least distinction na what we said 1 plus d by f. If it is at infinity, it will become d by f. So now I will be writing for the least distinction. What I said, nama magnification of the objective, which is nothing but VO by UO into what is that? 1 plus d by FE. Sorted. Magnification at infinity, what is going to be that? Can you give me the equation, everybody? It will be coming as VO by UO. There is no confusion. And here it will be simply d by FE. Just substitute from there. Okay, nama eyepiece oda equation da inge irukke. Objective oda equation vanda it is not going to change. Purinjada everybody? Yes or no? Please let me know. Quickly, please let me know, everybody. ஏன்னா வந்து we are going for the astronomical telescope. Okay guys, மறக்காம like பண்ணிக்கோ everybody. astronomical telescope சொல்லும்போது இதுல வந்து again நம்ம normal adjustment இருக்கு and also least distinguishன்ல இருக்கு. so normal adjustmentல சொல்லும்போது magnification வந்து FO by FE தான். and அந்த ஒரு கேஸ்ல நம்ம tube length நமக்கே தெரியும் இந்த astronomical telescope ஓட tube length வந்து கொஞ்சம் bigger தான். ஓகேவா? so அதோட tube length வந்து it will be coming as நம்ம focal length of the objective plus the focal length of the eyepiece தான். yes, hi Lokesh. Hi. Yes, Kavi, astronomical telescope. Okay. So next one the pathena, if it is at the, which means if you need to get the image at the least distinction, nama magnification or expression vandu idudha FO by FE into 1 plus FE by D. And also அந்த ஒரு கேஸ்ல tube ஓட length வந்து FO, focal length of the objective plus the objective, or let's say nama object distance for the eyepiece. Got it, everybody? Yes, Venkatesh. Hello. Yes. So this is what we need to study in the what is in our optics. Quick, we have discussed about the optics. Even if we say quick kanalum, it got almost 1 hour for the ray optics. Can we go for the wave optics? Ninga ready now? Put some fire in the chat box because I wanted to see more fires. Everybody. Astronomical simple da astronomical telescope la again magnification we need to find it for two cases. One is for the normal adjustment, which means the object is at infinity. Another one is nothing but least distinction la you need to get the image. Appadina in the oru case la magnification is going to be very simple, FO by FE, sorted. And when it comes to here at the least distinction, FO by FE irukattum, and other way we have to do it for the 1 plus FE by D. Okay, so now let us go for the wave optics. So in the wave optics la first one the introduction part வந்து exacta நம்ம waves chapter la whatever we have studied adudha வந்து இங்க கூட we have going to say. And right now you can do one thing, மறக்காம channel subscribe பண்ணிக்கோ, also like this session. Okay, நீங்க வந்து அந்த like button press பண்ணலடா. Okay, I know you forgot, you are not doing anything what is intentionally, I know it. Okay, so மறக்காம check பண்ணிக்கோ. Okay, so இப்போ வந்து பார்த்தேனா நம்ம superposition of interference of light da. Okay, நம்ம superposition of interference of light da. So first வந்து we should know the equation connecting the path difference and the phase difference. So நம்ம phase difference phi will be equal to 2 pi by lambda into delta x. Delta x na என்னடா நம்ம path difference da. In the path difference usually we will mention in terms of lambda. Understood everybody? Yes or no? So adukapra nama resultant amplitude da, let us say we have two waves with the waves with y1 which is equal to a1 sin omega t, y2 with the a2 sin omega t plus 5, which means there is a phase difference. Okay, two waves irukku ana vandu phase difference irukku, different ana amplitudes da. Appadina nama resultant wave oda amplitude if you need to find na, what is the equation? Root of a1 square plus a2 square plus 2a1 a2 cos theta. Simple as சொன்னிட்டேனா மேம், இந்த மாதிரி இவ்ளோ equations எல்லாமே வந்து ஸ்டோர் பண்ண முடியாது மேம், ரொம்ப கஷ்டமா இருக்கு அப்படினா you know how to handle vectors, right? You know how to handle the vectors, correcta? அப்படினா we will just keep the a1 vector இப்படி. Okay, amplitude வந்து it is not a vector, ஆனா வந்து to find the resultant amplitude we will consider it like a vector. So இது வந்து amplitude வந்து a1 தான், this is what a2, இதோட phase difference என்னடா 5. Okay, if you got this two vectors with the angle between them, you know how to find the magnitude, you know how to find it, correct? It will be coming as root of a1 square plus a2 square plus 2a1 a2 cos theta, root of a square plus b square plus 2ab cos theta. Exactly similar to that, a and b will be replaced it as a1 and a2, which means the amplitudes. Clear ada everybody? Can you give me a black forest quickly? I'm missing the forest. Okay, so this is what the thing. And also we know that number intensity and the amplitude is having a relation. Can you give me the relation over here? What kind of relation they have? Ma'am, அந்த மாதிரி relations எதுவும் we are not even looking at that, ma'am. Okay, அப்படி இல்ல, நம்ம intensity and amplitude வந்து I is proportional to a square தான். Okay, I is proportional to amplitude oda square தான். So அப்படினா இந்த ஒரு equationல I'm going to replace with the intensity. அப்படினா a1 square சொல்லும்போது what is that da? It is I1. a2 square சொல்லும்போது என்னடா I2. and to A1, A2. A1 na it will be proportional to root I1 da. So root of I1, I2 cos phi. So intensity part also done. We are not studying anything new. We just study the phase difference and path difference order relation. Adukapram we have just deal two equations of waves. Adoda resultant amplitude sollumbodhu we will just consider the vectors. Okay, and the vectors order equation la just we will replace A1 and A2 with the AB with the A1 and A2 and phase difference da inga vanda in the vectors kulla irukra angle and the madri we will imagine and we will do. Next vanda in the madri we need to get it for the intensity as well. Appadina we know the relation intensity is proportional to A square. Appadina A is proportional to root I. So I'll be just replacing this equation as well. Next வந்து இன்னும் ஈஸியா இருக்கு which means exactly in vectors how we have studied. Okay va, how we have studied nama what to say மறந்தே போட்டேன் what I was talking about. Yes, vectors. Okay, vectors la ipo vandu magnitude of vector A and B is same. What will happen? How will be the equation changes? Exactly the similar way we will write it over here as well. 4I0 cos square 5 by 2 it will come. So you guys have to study all this equation. I think you have written all the equations correctly. Now let us go for the constructive destructive interference. Okay, so tell me quickly, what is this constructive interference? Interference na two waves will combine. Okay, it will superimpose and it will be giving the new one. Correct allada? So constructive interference sollumbodhu what is the phase difference? What will be the phase difference? It will be nothing but 2n pi da. Correct allada? So when I'm talking about very good maximum amplitude, maximum intensity. So constructive interference ku adoda phase difference vanda it will be 2n pi da and n can be 0, 1, 2 etc. Got it everybody? And what should be the delta x value? Nama path difference and the equation la substitute pannalam. Don't study anything new. 5 வந்து you study constructive interference காக what should be the phase difference அது வந்து இங்கே you can study. இப்போ வந்து path difference find பண்ணனும்னா we already studied this equation இல்லையாடா delta phi which is equal to 2 pi by lambda into delta x. In the equation use பண்ணி you can find the delta x as well and you will get to know this is nothing but n lambda. The path difference will be coming as n lambda. And now tell me what is going to be the maximum intensity. What is the maximum intensity? We know that when it comes to 2n pi, okay, when it comes to 2n pi na definitely நம்ம maximum intensity oda value வந்து it will be coming as root of I1 square plus root of I2 square. This is what the expression which is coming for the maximum intensity. புரிஞ்சுதாடா? Constructive interference oda phase difference, path difference, maximum intensity oda expression. Next one the destructive da. Okay, so if you know this, better go for this destructive interference. Interference la phase difference one the 2n minus pi, which means we should get the odd number. Okay, we should get the, let us say if I'm just talking about 2 into 1, which will be 2 minus 1, so it will become pi. When it comes to 2 into 2 it will become 4 minus 1, so which means and the pi oda coefficient வந்து அந்த number வந்து it has to be a what odd number ஆ இருக்கணும். Okay, it has to be a odd number. So path difference will be again 2n minus 1 into lambda by 2 it will come. And destructive interference na you will be getting the minimum intensity. So on the minimum intensity will be, we know that இது வந்து again vector oda thing da. When we need the maximum what to say value for the vector now, that is coming as when theta is equal to 0 degree. Correct? So அப்படினா அந்த ஒரு டைம்ல we used to say a plus b whole square. இங்க வந்து a னா root i1 தான், b னா root i2 தான். ஓகேவா? மினிமம் சொல்லும்போது okay, minimum சொல்லும்போது Geraldine we have already taken 11th da. We can just check in the live session. And upcoming days I'm going to plan to take it again because ஏனா வந்து I took it long back. Okay, so I'm just planning to take it on again. So let me just update you. Okay, in the next class I'll try to. Okay, what is the main difference? Main difference na Yoga Prasad, it will be coming as constructive interference la it will give a what is a more amplitude வந்து higher இருக்கும். When it comes to what is a destructive interference, amplitude வந்து கம்மியா இருக்கும். அவ்வளவுதான். Okay, which means you can also mention in terms of intensity as well. Okay, next on the ratio of maximum to minimum intensity, which we know, and we will be just substituting it, and then again we will be just replaced with the amplitude. That's it. Okay, va? Understood everybody? Yes or no? So can we go for the next part? Nama Young's double slit experiment. Ready? Ready, everybody? And guys, marakama like panikoda. You guys are not liking the session. Yes, 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 yes. Yes, very good, Divya. Very good, very good, very good. So now we are going for the Young's double slit experiment. In Young's double slit experiment, we can see the path difference. Delta x value will be coming as d sine theta. So we know that if in the angle theta, if it is very small, we can approximate to, okay, sine theta, we can approximate to theta. So appadina we know that tan theta also, whenever we are getting this theta is very small, tan theta also we can just approximate to theta. Appadina d sine theta, I will replace it as d tan theta. So I'll be getting the path difference. Okay, I will be getting this delta x value, which is equal to y into d divided by capital D. Tell me what is y, what is small d, what is capital D? Capital D சொல்லும்போது நம்ம slit and screen இருக்கு. இதுக்குள்ள இருக்கிற distance of separation தான் capital D. And when it comes to small d, நம்ம slit குள்ள இருக்கிற அந்த difference தான் நம்ம small d. And what is y? Y is nothing but the நம்ம central maxima இருந்து அந்த where we are finding this one, அது வரைக்கும் இருக்கிற distance தான் நம்ம y value. புரிஞ்சுதாடா everybody? Yes or no? 13 more likes, guys. Smash it, guys. Why you people are not liking the session? Just check. Maybe you are just listening the class and the spirit you forgot to like the session. Now you just check. You can see and the like button dark color illa. So just make it dark. அதுக்கப்புறம் இந்த மாதிரி ஒரு லைக் பட்டன் இருக்கு, அந்த லைக் பட்டன் டச் பண்ணாத. Okay, so right now this is what the path difference. And also major we can expect more questions from the Young's double slit experiment. So if you need to find the nth bright fringe, we know that alternate dark and bright fringe will be coming in the Young's double slit experiment. If you are seeing the screen, you can see alternate light. Hey, you people are talking about like, and I'm saying alternate like buttons you can see. Okay. Yes, exactly, Kavi. Very good, very good. Anusha, hi guys. Just listen here, da. Okay. The waves are about to interfere. Let's make sure our support is constructive interference. Oh my God, Jia. Oh my God. Oh my God. ரொம்ப creative இருக்கேன்டா. Last class la kuda இந்த மாதிரி you have mentioned something, right? Okay, yes. Very good, very good. Okay, and the madri you could think and you can just make it to a thing. No, that is very, very good. Okay, you can think. Perfect. Okay, so let us see. So upon the nama bright fringe order position, also we need to know the dark fringe order. What to say? What to say? Nama on the central maxima la irundhu irukra distance. Adukku da nama n lambda d divided by d. And also if it is a dark na, inga odd number varanum. So adu mattum da you have to think. So it will be coming as 2n minus 1 divided by 2. And you will be get it. Okay, same exactly y value what we have studied. Anga we have studied. Okay, so you will be just substituted with the number 2n minus 1 by 2 for the dark, and for the bright it will be simply n. Next on the fringe width, the fringe width na in the 2. Okay, we have two bright band. Okay, so in the two bright band kulla irukra oru distance illana two consecutive dark fringe kulla irukra and the distance adha which means and oru dark band oda width da nama fringe width. Okay, we will usually represent it as beta. So appadina it will be coming as lambda d by d. Okay, so central maxima irukum, adukapram you will be getting, okay, if you are just going for the first one, you can just go for the lambda d by 2 into 1 bright fringe kaga. And if you need to get the dark fringe na, you can just go for 2n minus 1 divided by 2 into lambda d by d, which means nama fringe width. Got it? Everybody understood? Yes or no? Yes or no? Please let me know through your favorite heart, everybody. Everybody, please let me know. Please let me know, Kwikka. Yes. So now on the we have understood நம்ம central maxima இருக்குல்ல. So அந்த central maxima ஓட angular width வந்து angular width சொல்லும்போது let us say இதுதான் வந்து நம்ம what is it நம்ம fringe. Okay, so இப்போ வந்து இதுதான் வந்து நம்ம source. So this is what the angular width, and the angular width வந்து it will be coming as lambda by d, or let us say we can just write இப்போ வந்து fringe width ஓட terms ல தான் if it is given na, you can just, ma'am can you say again what is d? Okay, capital D வந்து நம்ம slit and the screen. Okay, screen இருக்கும்ல, இந்த dark and bright branches, I mean fringes வரும்ல, so இதோ இந்த ஒரு distance தான் D. And நமக்கு we know that நம்ம slits இருக்குல்ல, Young's double slit experiment தான், so double slit இருக்கும். So இந்த slitக்குள்ள இருக்கிற ஒரு small difference இருக்கும், that is what small d. Got it? Okay. And now, so now what we were discussing, yes, nama angular width da, angular width will be coming as lambda by d, illana in terms of fringe width you can say beta by capital D. Got it? Next one enna, in the fringe width da, ana vandu we are introducing a glass slab. So when it comes to a glass slab, what basically happen, nama in the what to say, in the light oda path illada, it will be get, okay, and the speed வந்து reduce ஆகும். அந்த speed reduce ஆகும்போது நம்ம path difference ல கூட அந்த difference வந்து பார்க்கலாம். So previously we said நம்ம path difference வந்து n lambda தான். இப்போ வந்து இந்த glass slab இருக்குதுனால அந்த glass slab ஓட refractive index வந்து mu தான். So definitely this path difference will be turned out to be mu minus 1 into t. T னா அந்த glass slab ஓட thickness தான். Okay வா? mu னா அந்த glass slab ஓட refractive index தான். So if there is a glass slab introduced in between na, nama path difference will be mu minus 1 into t da, and same thing will happen for the central. Okay, nama central maxima kuda it will shift. Okay, it will shift, and the shift order value vandu it will be d by d into mu minus 1t, or in terms of fringe width you can just go for, okay, what happened, who is spamming there? Elma, we are already doing this, no? Parallelly we are doing that repeated questions, most repeated questions எல்லாமே வந்து பண்ணிருக்கேன்டா, and it's still continuing as well. இது வந்து every day students were asking this complete physics வந்து அன்னைக்கு finish பண்ண முடியல, volume 1 மட்டும் தான் finish பண்றது. So right now I'm just going for this. Guys மறக்காம like பண்ணிக்கோ. 4 more likes guys, 4 more likes. Feeling so sad. Wait, Divya, what happened Divya? Ma'am, please solunga. I saw that. I couldn't read the previous one. Okay, let it be. So right now, this is what the shift. Okay, idu vanda rare tha, it is asked. Analum, it is asked already. Okay, so right now you can just study this equation. Just understand whenever we are just introducing the glass slab, the path difference la change irukum, and nama central maxima oda position kuda it will change. Okay, so now we are going for the diffraction. So tell me, what is diffraction? What is diffraction? Ma'am, if I cover the marathon and PYQ, can I solve 35 questions in the main NEET? How many marathons, how many questions you will solve? And the base pani I will tell you. 3 more likes can choose. Okay, as I mentioned, ninga vandu avlo involve work in the class la. So now you people are not even seeing like பண்ணிருக்கா இல்லையா, confused இருக்கு. இப்போ வந்து செக் பண்ணும்போது okay அங்க dark color இல்ல, so make it dark and come back. Okay, so yes, questions in the inneke and the questions we are not going to solve Anusha, we will solve questions in the upcoming classes. Okay, நாளைக்கு கூட ஒரு session இருக்குல்ல 10 am க்கு, அதுல join பண்ணிக்கோடா Anusha. We will cover questions plus concepts. Yes, when the light is actually falling on the corners, or let us say it is passing through a slit, நாங்க வந்து லைட்டுக்கு ஒரு bending இருக்கும். ஓகேவா, அந்த bending தான் actually வந்து we are saying it as diffraction. So right now do like the session guys, bending and spreading. Very good Elma, very good. So this is what the thing. So right now நம்ம slit oda width வந்து இது வந்து single slit தான். Okay, so நம்ம previous caseல actually வந்து double slit தான். I am the 100th like Hema. Okay, so right now nama slit oda width vandu a da, adu vandu avlo small, it is actually a. Now the thing is like we should get the what to say, the central maxima will be there, let it be there. I'm just talking about, we know that nama pattern vandu it will be, there will be a central maxima. அதுக்கப்புறம் நீங்க வந்து பார்த்தேனா இது வந்து intensity வந்து reduce ஆகும். Same it will be happening this side as well. The intensity will reduce, it will go. So I'm talking about the secondary minima. Secondary minima enna dark fringe da. Okay va, dark fringe da. Target achieved. Very good. Super. Okay, and guys, நம்ம target வந்து again we are going to change it to 200. Now you can make it to 200 immediately. So now focus over here. So now the thing is like நம்ம what to say, நம்ம dark fringes ஓட secondary minima வந்து find பண்ணனும்னா அதுக்கு வந்து you can just use this equation. Yn will be coming as n lambda d by a. So இங்க வந்து பார்த்தேனா just note it. Okay, just note it. இப்போ வந்து நம்ம ப்ரீவியஸ் கேஸ்ல நம்ம யங்ஸ் டபுள் ஸ்லிட் சொல்லும் போது அங்க வந்து கன்ஸ்ட்ரக்டிவ் இன்டர்ஃபரன்ஸ்ல தான் ஓகே த இன்டென்சிட்டி மேக்ஸிமம் ஆகுற இல்லைன்னா பிரைட்ல தான் ஆக்சுவலா வந்து வி யூஸ் டிஎன் ஓகேவா இங்க வந்து மினிமத்துல தான் சோ ஜஸ்ட் ரிமெம்பர் லைக் திஸ் வே அங்க வந்து டார்க் அங்க வந்து பிரைட்ல தான் இங்க வந்து we are using n for the dark fringes and when it comes to the secondary maxima okay previously it was 2n minus 1 ஓகேவா இங்க வந்து 2n plus 1 into lambda by 2 okay so just note பண்ணிக்கோ you have to study this as well so when it comes to diffraction நம்ம secondary minima ஓட position வந்து we can just find it using this and secondary maxima ஓட position வந்து you can just find it using this equation 2n plus 1 previously நம்ம what to say minima find பண்றதுல we use 2n minus 1 ஆனா வந்து இங்க வந்து maxima தான் 2n plus 1 got it perfect so just compare and just study okay we will do the formula revision also annekku kuda you will get more clarity on this so next வந்து நம்ம central maxima da so central maxima சொல்லும்போது அதுக்கு வந்து width இருக்கும் and also நம்ம angular separation previously whatever we have mentioned so அதோட expression da so width வந்து 2 lambda d by a da so lambda வந்து wavelength of the light da d na நம்ம screen and this slit ல இருக்கிற அந்த difference da when it comes to the a ina நம்ம slit ஓட width da angular width சொல்லும்போது which is nothing but 2 theta which is equal to 2 lambda by a understood can you give me a red velvet in the chat box quickly everybody ஏனா வந்து இதுல வந்து we just need to study one more topic அதுக்கு அப்புறம் நம்ம wave optics வந்து finish ஆருக்கு everybody so in the equations எல்லாமே வந்து you have to follow you have to study as well next வந்து நம்ம polarization தான் okay polarization தான் ஓகேவா polarization of light so நமக்கே தெரியும் நம்ம light வந்து it is actually having multi directionல இருக்கு okay so அந்த ஒரு டைம்ல அந்த intensity வந்து ஹையா இருக்கும் so that is why in the noon timeல whenever we are just going out we will feel like this oh my god what a light correct okay even when you wake up late in the morning also what your amma will just open the curtain okay then also you will feel like hey what is this correct so that is why the intensity ஏனா வந்து நம்ம what to say da game over Hajar game இன்னும் ஓவர் ஆவலடா we just started now only okay so now what I was just talking about இப்போ வந்து பார்த்தேனா நம்ம லைட் வந்து it is actually இப்படிதான் multi directionல தான் okay multi direction தான் so when we are just passing it through a polarizer it will become like this so then I will say this is got polarized okay this got polarized so this is what the polarization process so இப்போ வந்து ஒரு unpolarized light when we are just keeping or when it is passes through a polarizer then அதோட intensity வந்து exactly it will become half of it okay initially இருந்த intensity விட half ஆ இருக்கும் next வந்து Malus law தான் இது வந்து டைரக்ட்டா நம்ம syllabusல mention பண்ணல but just study this equation okay just study this equation I which is equal to I naught cos square theta okay va so this is what the thing and what is theta nama polarizer and analyzer ஏனா வந்து when we are talking about this polarization usually it will passes through the polarizer அதுக்கு அப்புறம் what is happening there is an analyzer அந்த நேம்ல இருக்கு okay we will just analyze whether it is polarized or what so அதுதான் வந்து analyzer ஓட duty so இந்த two things உள்ள இருக்கிற அந்த angle தான் actually வந்து theta okay so the light is coming here let us say here is the polarizer and again when it comes to the what to say analyzer it will be like this so இந்த ஒரு கேஸ்ல whenever this analyzer will be just tilted definitely it will be making an angle okay this definitely it will be making an angle so this is what theta so you can just study this law ஏனா வந்து டைரக்ட்டா இது வந்து syllabusல mention பண்ணல so definitely it is not going to I mean chances வந்து கம்மி தான் ஓகேவா so Malus law next வந்து Brewster's law தான் இது வந்து clear-ஆ specify பண்ணிருக்கு so you have to study as well so tell me what is this Brewster's law சொல்லிட்டேனா definitely நம்ம light வந்து it is falling on a surface okay va it is falling on a surface so it will go for reflection as well as refraction Okay va? Nama light is having a property, or let's say it will show reflection, diffraction, interference, everything. So ipo I'm just talking about two things. Two things enna, definitely in the light is incident on the surface, and what happened, reflection also happened, refraction is also happened. Ipo in the reflected ray and the refracted ray is making an angle 90 degree. Note panniko, what is the thing? What is the thing? Why Elma? Why this question mark? Okay, so what is the thing? When the reflected ray and the refracted ray is making an angle 90 degree. Okay, 90 degree it is making. Appadina there is an incident angle illiyada. And the particular incident angle the actually வந்து நம்ம Brewster's angle. Okay, so அந்த ஒரு கேஸ்ல what is the advantage? நம்ம reflected ray இல்லையாடா அது வந்து polarized ஆ இருக்கு. Simple புரிஞ்சுதாடா everybody? Yes or no? What happened Rida? What happened? Tell me. Why this is happening? Is there any problem with the video? Yes or no? Yes, da, exactly. Ma'am, sorry, I understood something was happened. Hanila, very simple, da, very simple. So, simple as only nama light it is falling on a surface. Okay, it is falling on a surface. If it is falling on a surface, na, reflection can, reflection can happen, or refraction will also happen. Light in the properties it will show, na. So definitely reflection, refraction, everything will happen. So when it comes to the reflected ray and the refracted ray, what is the thing? Reflected ray and the refracted ray is making an angle 90 degree. Okay, and the case, and the specific case one na. What is the advantage? Nama reflected ray illada. When it comes to us, it is actually polarized light. Okay, it will be a polarized light when if it is making the reflected ray and the refracted ray, if it is making an angle 90 degree with each other, then definitely nama reflected ray will be a polarized light. So that is what the Brewster's law and the specific incident angle. Okay, at a particular incident angle only in the 90 degree will come. Okay, not at any random angle it won't happen. Okay, va? So definitely at a random angle it will be coming as 90 degree. Appadina and the specific incident angle I will be call it as the Brewster's angle, which will be tan of that incident angle. Tan of the, is it at a reflecting surface, ma'am? Mada. Okay, let us say this is nama surface. Okay, light is falling like this. This is what the normal. Okay, va? So now this can go for reflection. This will also go for refraction as well. Okay, va? So what I'm saying, this angle is 90 degree. Okay, this angle is 90 degree. So on the 90 degree varumbodhu, nama incident angle I will be call it as Brewster's angle. And what is this reflected ray? Idu polarized da. புரிஞ்சுதாடா இது polarized da. Now you can just study this relation mu which is equal to tan of the Brewster's angle. Tan of the Brewster's angle. புரிஞ்சுதாடா everybody? So this is what the thing. Maller's law, if you want you can skip it for right now, but Brewster's law multiple years la it is asked, so you have to be very confident about it. Okay, done everybody? Yes or no? Yes or no? Okay, okay, so let us go for a quick break. We can just take a break. Okay, adukapram we can go for the modern physics and semiconductors. Ready everybody? I also need to take some water and I need to sit for some time because I was taking a lot of my volume is actually everybody can hear what I'm saying here. Okay, இது sound proof da, ஆனாலும் இன்னைக்கு என் sound everyone will listen. Okay, இதுக்கப்புறம் I will ask them what are the things I have taught them. Okay, so when we can resume? Tell me the time. Yes. Yes, 7:50. We will resume at 7:50. Okay, so see you guys, take a proper break and just you should come back. Okay, don't cheat me, come back. Yes, Tania, 750, 750, 750. Yes, of course, Nila. Hardly even the 4 more chapters. In the modern physics one, I will finish in 30 minutes. Adukapram semiconductors, I will finish in 20 minutes. Done over. Okay. So you guys have to come back by 750. If you are not coming back, I will just stop this and I will go. Okay. Don't make me in a kind of what to say. I don't want any kind of heart attack because I'm doing this for you people, right? இதுக்கு வந்து எனக்கு extra energy தேவையா இருக்கு because we need to go a little faster. So of course I'm taking little bit more energy. So make sure you people will be coming on time. Okay? Yes. Thank you. Hello, everybody. Am I audible? Yes or no? Yes, yes. So many cheating people are there. You didn't come back on time. So that was actually I was just crying. Okay, so let us just start with dual nature. அதுக்கு முன்னாடி let me just show you நம்ம free re-NEET crash course இங்க இருக்கு. இந்த ஒரு லிங்க் கிளிக் பண்ணா போதும். You will be going to our app and you can see here zero priceல you are going to get the free re-NEET course. Sorry, free re-NEET course. So in the course இதுல நீங்க வந்து பார்த்தேன்னா you can see நம்ம physics, chemistry, biology classes and also you can see the test. Okay, நம்ம டெஸ்ட் இங்க இருக்கு. So you can just attend the test also. ஏன்னா வந்து last few daysல எல்லாமே வந்து this is very important. And 24/7 நம்ம doubt solving. Even if you are studying, ma'am, your face is dull because you people didn't come back on time. No, many students were just gone and that was making me so sad. That's why Takshin. Okay, but பரவாயில்ல. Okay, and now question bank அங்க கிடைக்குமா? So that you can just see in the test part. My test பார்த்தல அங்க வந்து you can see it. And நம்ம questions வந்து நம்ம doubts வந்து you can just solve using this here. Okay வா? So next வந்து நம்ம what to say நம்ம mock test தான். Okay, why it is happening like this? Okay, நம்ம mock test தான். நம்ம mock test பார்த்தேனா you can see here one link இருக்கு. அந்த linkல you can just go and 13th Juneக்கு வந்து you will be having a mock test and நம்ம தமிழ்நாட்டுல different ஆன VLC centersல இந்த exam will happen. So you can just go for the preferred location as well. இப்போ வந்து if you are just coming from Madurai, okay, how many of you are coming from Madurai? Can you just please let me know from where you guys are coming? So இதுல வந்து ஏதாச்சும் ஒரு பிளேஸ்ல இருந்து you can just choose and you can just go for submit. So what is the advantage? You will be getting a call from our team. So அந்த அன்னைக்கு வந்து you can just go and attend that exam and அன்னைக்கு கூட you will be getting the result. So definitely you will be what to say, you can just before the exam you will get a proper mock test. Okay, so ready for dual nature everybody? Trichy ma'am, I'm back. Yes Elma. Okay, so now we are going for nama favorite topic, dual nature. Ready ada? Chennai, Kanyakumari. So Jia, you know Malayalam very well, I guess so. Correct. Kanyakumari na it's Trivandrum, right? Yes, Puducherry. Yes. Maha it is from Chennai. Yes. Madhumida from Tirunelveli. Yes, Divya is ready. Ranjit is from Chennai. Okay, yes. So everywhere we have the center, so you can just check it. You can give the preferred location and you can just try it. You can just write the exam. Okay, Karaikudi. I heard this term. I heard this about this place. Okay, got it, Deva, got it. Yes. So now let us go for nama dual nature. So nama dual nature pathena first vanda we should talk about the photons. Okay. So tell me now, what is the energy of photon? What is the energy? What is the energy? Energy of a photon, it is nothing but h mu da, which is also equal to mu and the wave, nama speed of light divided by lambda da. So it will be coming as hz by lambda. Next வந்து நம்ம intensity தான். Okay, இந்த photon வந்து அதோட rest mass வந்து 0 தான் and it will always travel with the speed of light and it has momentum, it has energy. So அதுல வந்து பார்த்தேனா நம்ம momentum வந்து it is nothing but E by C. Okay, momentum வந்து I haven't specified here. So momentum of the photon வந்து it is nothing but E by C தான், or else I can say that this is nothing but H by lambda. ஏனா E na HC by lambda இல்ல. So we can say that நம்ம what to say நம்ம photonோட what to say the momentum வந்து h by lambda இல்லனா it is nothing but E by C. Yes da. இது வந்து எப்பவுமே சேமா இருக்கு. நம்ம சிலபஸ் சேஞ்ச் ஆகலல. So re-NEET ஆனாலும் same notes, same nothing. Okay. Yes. So right now நம்ம intensity da. Intensity சொல்லும்போது it is nothing but energy by time per area da. So I can just go for energy by time na power da. So power divided by A. Okay, power divided by area it will come. Next வந்து இப்போ வந்து இந்த intensity, if our source is from a point source தான். Okay, point source னா நம்ம பவரோட எக்ஸ்பிரஷன்ல it will be நம்ம இன்டென்சிட்டியோட எக்ஸ்பிரஷன்ல we know it is power by area தான். So area வந்து 4 pi r square தான். When it comes to linear source, it will be coming as power divided by 2 pi r l. Understood everybody? Yes or no? So இதுதான் வந்து நம்ம photonோட properties. Next வந்து radiation pressure. Radiation pressure சொல்லும்போது என்னடா? Radiation pressure na. Okay, our gang is missing. Where is? So you people are not including me in your gang. Okay, you people are not missing me. It's heartbreaking. Okay, guys, மறக்காம லைக் பண்ணிக்கோ. So radiation pressure na நம்ம லைட்டுக்கு ஆக்சுவலா வந்து it can exert pressure. Okay, it can exert some pressure. So when it comes to a reflecting surface na என்னடா? இதுதான் வந்து நம்ம reflecting surface. So the photon will come and fall on this, and after that what will happen? With the same momentum it will reflect back. அப்படினா நம்ம radiation pressure ஓட வேல்யூ வந்து 2I by C da. What is I? Yes. Okay. Shiva came in between but left. IG na Instagram. You're talking about Instagram. Yes, tell me what is I? I in intensity. Very good, Samiksha. It will be 2I by C. So 2 into intensity divided by C. So now you people have to give me an expression for the absorbing surface. Absorbing surface, it will come with a momentum h by lambda. And it won't reflect back. It will be get absorbed. Appadina, what is the radiation pressure? It will be coming as I by C. So this is what about the radiation pressure. Next one we know electron emission. Okay, electron emission. Electron can be emitted when it comes to energy in any of the source. Paravailla, if it got the enough amount of energy, it will reflect. It will escape. Okay, so adukkaga we can give thermal energy, which means heat we can give. So thermal energy if you are giving now, I will call that specific emission as, what was the emission? What was the emission name? It is nothing but thermionic emission. Ipo vanda and the energy I'm giving it through strong electric field. Then what I will give? I will be give as a name as field emission. I will be call it as field emission. Very good, Ranjit. Next one, if I'm giving light, okay, so energy I'm giving it through light na, I will be call it as photoelectric effect. Now tell me what is going to be the condition for the photoelectric effect? Everybody tell me. Yes, good evening Akshaya, good evening. Yes, tell me what is the condition for photoelectric effect? Photoelectric effect oda major ana condition enna, light it will fall on the surface. Correct? Light will fall on the surface. So when the light is falling on the surface, it should interact with the electron. Correct? In the particle behavior irukella, nama light la irukra particle behavior da nama photon. So in the one photon will connect, or let's say it will interact with one electron. So ipo vandu in the electronic emission happen, I mean if it needs to, நம்ம emission if it should happen na, அதுக்கு condition என்னன்னா இந்த electronக்கு enough amount of energy கிடைக்கணும். கரெக்ட்டா? enough amount of energy கிடைக்கணும். So அந்த enough amount of energy தான் actually நம்ம work function. So what is the work function? The minimum energy required. Okay, the minimum energy required for the electron to escape from the metal surface. Okay, to escape from the metal surface. That is what the work function. So the condition is nothing but the energy of the, okay, the energy of the photon should be more than that of the work function. Then only this photoelectric effect will happen. Understood? Can you give me a blue forest in the chat box? Everybody quickly. Can you give me a blue forest quickly? So work function vida more energy and the photon irunda mattunda we can go for the photoelectric effect. I love modern physics because of your lecture, ma'am. Thank you so much, Dora ma'am. Thank you, da. Even I forgot this Dora name because my hair is grown up. No, it does not looks like Dora right now. But I miss that. Now again I'm going to make it short. Okay, so now we understood about this condition. Appadina work function na H mu naught. Tell me what is mu naught? Mu naught na threshold frequency da. Threshold frequency na minimum frequency required for this electron. It should be less than that of the energy of the photon. So HH. So I can say that if it has to, okay, nama photoelectric effect, if it should happen, the condition is nothing but nama threshold frequency vida adhigama irukkanum nama frequency of the photon. So this is what the condition. Next one, the nama Einstein's relation. What is the Einstein's relation? Even though your hair has grown, you're always the cutest, Dora. Thank you, thank you so much. Okay. So right now, always you people are my buji. Okay. My buji always. So right now we understood the condition. Next one, the nama Einstein oda relation da. Einstein oda relation enada nama energy of the photon h mu is actually utilized for two purposes. What are the two purposes? First one is nama work function. And the electron extra, enough amount of energy kadakkanumla. That is what phi naught. Plus the kinetic energy half mv square. Correct? And also we know that we can just go Dora Mam with her bujis. Exactly. Okay. So, ipo vandu paatena, we got this relation, and also in the kinetic energy will become potential energy. So, andoru time I could say that h mu, which is equal to phi naught plus nama potential energy. Potential energy sollumbodhu E into Vs. Tell me what is Vs? What is Vs? Quick tell me da. What is Vs? Vs na adu vandu nothing but nama stopping potential da. Stopping potential na enna? In the electron, okay, getting some energy from the photon. Adukapram it will travel to the other end illada. Ana vandu here there will be a strong negative potential. Strong negative potential. So definitely strong potential, negative potential nala it cannot move forward. So அந்த ஒரு டைம்ல இருக்கிற specific potential தான் நம்ம stopping potential. Okay, nama stopping potential. Now we know that in the electron is escaping from the metal surface, it will travel with an energy, it will travel with a velocity v. So ipo vandu in the electron oda flow, what is electron oda flow? Current da. In the flow it has happened due to what? It is due to the photons, or let's say light. So I will specially call this current as photocurrent. Appadina in the stopping potential and photocurrent connect panni, I can give another definition for the stopping potential. Can you give me before that? Yes, of course, nama photon, electron will flow, and at some point it will come to zero. அந்த ஒரு மொமெண்ட்ல இருக்கிற potential, we can say that the potential at which the photocurrent becomes zero. Understood? Can you give me a black forest in the chat box quickly? So stopping potential is nothing but the current will be zero. The particular potential will be known as the stopping potential. So now we got two equations. H mu is equal to h mu naught plus half mv square. If we have changed the polarity, we could say that h mu naught plus E into Vs. E na electron oda charge da, Vs na nama stopping potential da. So next important ana oru thing enna, we need to study some graphs. Okay. So right now nama current and intensity. Okay, அதோட graph வந்து இப்படி தான் இருக்கும். Current and intensity. So what is the basic relation connecting this? Okay, so இப்போ வந்து intensity increase ஆச்சுனா, which means brightness increase ஆச்சுனா, what is the meaning? What you will understand? Photons ஓட number வந்து increase ஆச்சு. Brightness increase ஆச்சுனா more photons. Got it? Brightness increase ஆச்சுனா more photons da. More photons, which means more electrons will be ejected. One photon will interact with one electron only. Appadina more electrons will be ejected. Yena more photons irukke. So appadina definitely we could say that the current, the photocurrent and intensity is having a direct proportionality. Intensity is increased, which means brightness is increased. Okay, we cannot say that intensity exactly equal to brightness. So yena vandu I could say that intensity adhigama irukna, I could say that brightness is also going to be more. So when I'm talking about brightness is more photons, more electrons will be emitted, more photocurrent. So intensity and the photocurrent having a relation, it will be a direct relation. Understood everybody? Can you give me a blue forest quickly on the chat box everybody? And guys marakama like panniko. Next one enna, இப்போ வந்து நம்ம what to say, we are increasing the frequency. Okay, frequency increase ஆச்சுனா what is the meaning? நம்ம energy of the photon is becoming more. Correct? Energy of the photon is becoming more. Energy of the photon more ஆச்சுனா what will happen? நம்ம work function ல change எதுவும் வராது. Okay, even if the photon is having more energy நாலும் work function remains constant for that particular metal. So what will happen to the rest of the energy? What will happen to the rest of the energy? Quick-ஆ சொல்றா? Yes, definitely அது வந்து kinetic energy-ஆ convert ஆகும். The extra energy வந்து kinetic energy-ஆ convert ஆகும். அப்படினா to stop this electron, we should give more potential. Correct? We should give more potential for it. So what I'm saying, when the energy of the photon increases, to stop this photo current, to stop the flow of electrons, நம்ம potential வந்து it has to be more. அப்படினா energy increases, frequency increases, which means நம்ம stopping potential will also increase. ஆனா வந்து photo current ல ஏதாச்சும் ஒரு change இருக்குமாடா? When the frequency increases, what will happen to the photo current? It will increase, decrease, or remains the same? Quick-ஆ let me know. Quick-ஆ let me know everybody. Of course ma'am, there won't be any change. Photo current change ஆகணும்னா more photons இருக்கணும் ma'am. அப்படினா மட்டும்தான் more electrons will be emitted. So அது வந்து எனர்ஜியை டிபெண்டே பண்ணல ma'am. So definitely there won't be any change for the current, but definitely when frequency changes, energy of the photon will increase. Energy of the what is it? Yes, I forgot. I'm shouting. Yeah, that is true. Please reduce the voice. Thank you da. Irritating arka. Okay, so that is what the thing. Okay, I'm more conscious about this completion. Okay, I wanted to make sure this will be done within 30 minutes, the entire thing. That is why I'm just getting more and more conscious. Okay, when I'm getting conscious, I will forget about whatever happening around me. Even I will forget about my thought. Okay, so that is what the thing. Intensity increases, photocurrent will increase. Sure, Elma, it will increase. Ana vande energy, frequency increases, photocurrent will remains the same. Understood? Next one, if the intensity increase ஆச்சுனா, in the stopping potential will change or what? Intensity increase ஆச்சு. So stopping potential will increase or decrease. Quick-ஆ let me know. Definitely nothing will happen. Stopping potential will remain same if the intensity increases or decreases. Never matter for the stopping potential. Got it? So these are the graph which is coming over here. Next வந்து இந்த ஒரு graph தான். இந்த ஒரு graph சொல்லும்போது we know h mu which is equal to h mu naught plus EVS. Correct? So now I just wanted to plot the frequency versus Vs, which means I want Vs on the y-axis and frequency along the x-axis. So right now, let me just rearrange this. H mu minus H mu naught divided by E will be coming as Vs. So H by E into mu minus H mu naught divided by E, which is equal to Vs. இந்த ஒரு part வந்து constant தான். Okay, so இப்போ வந்து if I'm just comparing with the y is equal to mx plus c பார்த்தேனா, நம்ம constant value c வந்து the y intercept will come as h mu naught by e, and I could say that நம்ம slope வந்து h by e தான். Whatever be the cases, whatever be the frequency increase, frequency decrease, whatever happened, will the slope will change? Will the slope will change? Please let me know. It will be always remain same. ஏனா h value வந்து constant தான், e value வந்து constant தான். So எப்பவுமே we will be getting நம்ம slope வந்து it will be same. Depending upon the work function, in the y intercept will change. Okay, it will change. Understood everybody? So this is very simple. When it comes to the slope, it will be same. It will be always h by e. Ana vanda when it comes to the y intercept, okay, when it comes to this point, this is completely depending upon the work function. Yena vanda work function divided by e da vanda nama c value. Got it everybody? Can you give me a yellow heart quickly? Yes or no? Yes or no everybody? Quick up. Everybody. And marakama guys, you can just like the session. இப்பவே லைக் பண்ணிக்கோ. Yes. Understood, Atakshan. Understood. No worries. I can understand. Okay. My students illada. நீங்க வந்து if you are just saying something, now I can just understand the tone also. Because it's been almost around 5 months, right? I think I have started taking classes in the mid of Feb. Okay, so almost I think 4 months. Okay, so definitely in the 4 months la I can understand your tone also da. Okay, so no worries, no worries, I won't think anything. Okay, so next வந்து என்னன்னா நம்ம de Broglie waves இல்லனா matter waves தான். Okay, de Broglie, yes Madhumita, it will finish in 30 minutes. I'm just telling you 30 minutes la finish பண்ண போறோம். Okay, so right now when it comes to the what to say de Broglie waves. De Broglie waves na enna, இப்போ வந்து லைட்ல பார்ட்டிகல் நேச்சர் இருக்கு, அதுதான் வந்து ஃபோட்டான். இந்த மாதிரி நம்ம பார்ட்டிகல்ல வேவ் நேச்சர் கூட இருக்கு. வேவ் நேச்சர்னா என்னடா, வேவ் நேச்சர் doesn't, okay, because we are your bitches. Yes, exactly da, exactly Dakshin, so much of love, so much of love. I really wanted to see you people da, actually when it comes to a conversation like this, I really wanted to see you people, and I don't know how to tell my excitement. Okay, so let it be, let us just focus over here, let us just finish in 30 minutes. Okay, so now the thing is like de Broglie waves da. De Broglie waves na enna, நம்ம மேட்டருக்குள்ள என்னன்னா நம்ம பார்ட்டிகல்ஸ்க்குள்ள அதுல வந்து வேவ் பிஹேவியர் இருக்கு. ஓகேவா, வேவ் பிஹேவியர்னா, okay, yes ma'am, you also, yes da. Of course. Okay, so right now we are talking about the de Broglie wave da. Adoda expression வந்து it is nothing but h by p. Okay, so இங்க வந்து பார்த்தேன்னா I have given the different equations for it. h by p, P na momentum da, so I'm just replacing it as mv. And also இப்போ வந்து mv na, okay, mv momentum in terms of kinetic energy, it is nothing but root 2m into kinetic energy da. அதுக்கப்புறம் நீங்க வந்து பார்த்தேன்னா if you are just going for the gas na, in the E value will be coming as 3/2 kBt da. So when you are substituting that value, you will be getting h divided by root of 3 kt. Understood everybody? Let me know. Next session வந்து நாளைக்கு morning 10 o'clock session இருக்கும். Okay, so this is what the things we need to study in the dual nature. Now let us go for the atom. Okay, so நம்ம ஆட்டத்துல பார்த்தேனா, so definitely we should discuss about the different Thomson's atomic model, Rutherford's model and Bohr's atomic model. Okay, so I'll be more focused on this Bohr's atomic model. ஏனா வந்து questions வந்து they will be asking mostly from the Bohr's atomic model. Okay, so the rest of the things you can just read it, how this what is alpha scattering experiment and all. Now it is, I'm just focusing on the Bohr's atomic model. So Bohr's atomic model சொல்லும்போது he was just talking about, okay, we know that in the electrons are actually, ma'am, rocking session ma'am, but also konjam tips kodunga ma'am at the end. Sure da. Okay, 10 o'clock da, 10 o'clock. Okay, so right now guys, மறக்காம லைக் பண்ணுடா, மறக்காம லைக் பண்ணிக்கோ. So now the thing is like இப்போ வந்து we know that this is actually moving in a circular orbit. Correct? It is actually moving in a circular orbit. Circular orbit சொல்லும்போது definitely if any object, anything, anybody is in a circular path na, அதுக்கு வந்து definite சொல்லும்போது it should have the centripetal force. What is the equation for centripetal force? Can you give me in the chat box? Centripetal force na mv square by r da. And in this case, okay, in case of this atom, in the centripetal force is given by the electrostatic force. இதுதான் வந்து நம்ம Bohr's atomic theory oda first postulates. Second one வந்து பார்த்தேனா it will be actually in the circular path la, yes, very good Rida, very good Fatima. So when it is moving in a circular path na, அதுக்கு வந்து ஒரு angular momentum இருக்கும். Angular momentum oda equation என்னடா? What is the equation? It is nothing but m into v into r da, which will be very, it's looking so beautiful. Okay, so which will be nothing but n times h by 2 pi da. Okay, it will be coming as n times h by 2 pi da. Next postulate என்னன்னா, when in the electrons will go to the higher energy level or it will come back to the lower energy level, இந்த ஒரு processல definitely it has to release some energy, or let's say it has to absorb some energy, which means if it needs to, okay, இப்போ வந்து இந்த electron வந்து இங்க தான் இருக்கு. Okay, so if it gets some energy na, it will go to the higher energy level. அந்த ஒரு டைம்ல it will absorb a photon. So இப்போ வந்து நம்ம செஷன்ல when my energy is decreases, what you people will do? You people give some hearts and energy will increase. அந்த மாதிரி இந்த electronக்கு it should absorb a photon and it will go to the higher energy level. Correct? And also when it comes to higher to lower, So it has to reduce its energy. So definitely what will happen? It will release the photon and it will come to the lower energy level. So in the when it absorbs the photon, when it is emitting this photon, definitely it will be releasing some on the process, on the process, we can see some emission and the absorption spectra as well. Another important thing regarding this atom is nothing but the radius of this atom. Okay, so radius of this atom சொல்லும்போது it is depending upon the orbit, at which orbit it is. Okay, so இப்போ வந்து பார்த்தேன்னா நம்ம Rn will be, don't study this and all, just focus over here, 0.53 n square by z, which means at least study this relation. நம்ம radius in the nth orbit, which is proportional to n square by z. இப்போ வந்து velocity of the nth orbit பார்த்தேன்னா it will be proportional to z by n. Energy பார்த்தேன்னா energy will be proportional to z square divided by n square. What is the equation for this energy? Energy oda equation வந்து 13.6. Okay, இது வந்து total energy வந்து always it is going to be minus, ஏனா வந்து it is bound to the nucleus, right? Okay, இப்போ வந்து இவ்ளோ energy, okay, whatever be the energy, energy oda expression என்னன்னா 13.6 z square divided by n square தான் this much of electron volt. If I am giving this much of energy na mattunda, it can come out of it. Okay, and the electronic one, if it needs to escape from the atom na, we should give this much of energy. Adanalata we have given minus 13.6 z square divided by n square we are doing. Okay, so next one I'm just giving the whole energy. Okay, time period order relation one I have given. Next one the kinetic energy, potential energy and total energy order expression da. So you can just go through it and just try to understand the kinetic energy and the potential energy. Can you just give me the expression? What is, if you know the potential energy, how you will be finding the kinetic energy? Very simple, minus 1 by, or else I can go for minus 2 kinetic energy will be equal to the potential energy. Can you give me the relation connecting the total energy and potential energy? Everybody give me the relation connecting total energy and potential energy. Of course, it is, again, it will be coming as 2 times the total energy will be coming as u. And try to understand kinetic energy will be always positive. Potential energy and this total energy will be always negative. Okay, in the oru relation vandu you have to study. No Elma, it is not u is equal to minus t, adu vandu wrong da. U is equal to minus 2t da actually, sorry, plus 2t da vandu, yena vandu negative, it's already there. Okay va, understood? Everybody got it? 2t will be potential energy. Got it everybody? Give me a yellow heart quickly if you understood this part. Everybody. So next vandu enna nama wavelength da. Okay, so when it is releasing some energy, when it is coming from a higher energy level to the lower energy level, definitely, paravalla Fatima, paravalla, okay, just make mistakes right now, don't repeat for the exam, avloda, okay va? So when it comes to emission spectra, okay, while it is releasing the photon, it should have some kind of, what is a wavelength, and the photon ku vande wavelength irukanumla. So that is what we will be doing. By doing this, we will be getting the wavelength, which means Rydberg constant into 1 by ni square minus 1 by nf square into z square. Ni na enna? Initially irukra energy level. Okay, maybe it is at the 5th level ah irkalam. So appadina in the 5th la irundhu it is coming to 3rd level. Appadina ni will be 5, nf will be, it is coming as 3. Got it? So now when it comes to hydrogen, we will be having different set of spectral lines. So Lyman, Balmer, Paschen, Brackett and Fund. And ipo vanda Lyman na, what is the thing? Nama final level vanda, it should be the ground state. Ground state solitena, n should be equal to 1. So now if I'm saying third excited state, okay, ground state I said it is n is equal to 1. So I'm talking about third excited level. What will be the n value? What will be the n value? Isn't it 3 ni? No da. No. Tell me, if ground state la n is equal to 1 da, if I'm saying third excited level, what will be the n value? Very good Maha, it will be coming as 4. Okay, it will be coming as 4. And the highest energy level is Ng. I'm not getting it. Okay, so இது வந்து emission da, highest energy level வந்து it will be initial இருக்கிறது, அதுக்கப்புறம் it will come to a lower energy level. Very good, n will be equal to 4. Guys, மறக்காம like பண்ணிக்கோ, also subscribe the channel, and also you can see in our description box there are many what is valuable things are there, so just use it. So இப்போ வந்து பார்த்தேன்னா லைமேன் சொல்லும்போது நம்ம ஃபைனல் எனர்ஜி வந்து ஓகே ஃபைனல் எனர்ஜி வந்து இட் ஷுட் பி த வாட் இஸ் நம்ம லோவர் ஐ மீன் நம்ம வாட் இஸ் கிரவுண்ட் ஸ்டேட்டா இருக்கணும் என்ன எனிதிங் மோர் தென் ஒன் ஓகே first excited state இருக்கலாம் second excited state இருக்கலாம் third excited state இருக்கலாம் it will be coming to the lower energy level which has to be 1 ground excited level. Next வந்து Balmer சொல்லும்போது from anywhere even from infinity it can come to the first excited level. First excited level now what is the n value? First excited level now what is the n value? It will become 2. So from any level from infinity from what is 11th energy state illana from 12th from 9th from 7th anywhere it will be come to the n is equal to 2. Then I will call it as Balmer. For passion it will be n is equal to 3 and for bracket it will be 4 and fund it will be 5. Okay va, got it? So using this from infinity irundha if it is coming now what will be the values of this lambda adu vandu I have noted down here. You don't have to by heart this, you can also do it in the exam time. There is no much kind of confusion, there is no point of confusion there. And also these lines will be in UV, visible and infrared. Idu vandu you have to study. Okay, sometimes it was asked, not every time but it was asked. Okay, so this is what the thing. Now we have the what is a nama what is a nuclei. Okay, so when we are talking about nuclei, first one idhula important ana oru portion enna we should find the size of the nucleus. Size of the nucleus sollumbodhu we will always mention in terms of the mass number. Okay, so appadina the size vandu we will be talk in terms of radius which will be coming as r naught into 8 to the power 1 by 3. What is the value of r naught? R naught வந்து 1 femtometer da, which means 10 to the power minus 15 meter da actually வந்து நம்ம r value. புரிஞ்சுதா everybody? Guys மறக்காம like பண்ணிக்கோடா. You people have forgot to like the session. Okay, right now itself you can just go for liking the session. Also இப்போ வந்து subscribe பண்ணலனா now itself you can just subscribe the channel as well. So இதுதான் வந்து நம்ம radius. Okay, radius of the nucleus வந்து find பண்ணனும்னா you can just use this expression. And next வந்து density da. Density வந்து எப்பவுமே constant ஆ இருக்கும். Okay, density வந்து எப்பவுமே constant ஆ இருக்கும். அதோட value வந்து 3 into 10 to the power 17 kg meter per second da. And also when it comes to நம்ம ஐன்ஸ்டீனோட மாஸ் எனர்ஜி ரிலேஷன் தெரியும்ல, what is that ஐன்ஸ்டீனோட மாஸ் எனர்ஜி ரிலேஷன்? இப்போ வந்து இந்த மாஸ் ஆல்சோ கன்வெர்ட்டட் as எனர்ஜி, கரெக்ட்டா? இந்த மாஸ் ஆல்சோ கன்வெர்ட்டட் as energy. So when it comes to mass is converted as energy, here in this case we can see a mass defect. What is this mass defect? Mass defect சொல்லிட்டேனா the total mass of the nucleus. Okay, I'm just checking the weight or let's say mass of the nucleus. இது வந்து lesser than that of the mass of the nucleons. What is nucleons? Tell me what is nucleons? Nucleons na nothing but the protons and neutrons. Correct ada? It is nothing but the protons and neutrons. So nucleons oda individually I'm just checking. Okay, ivlo number of protons irukku, ivlo number of neutrons irukku, idoda mass vandu combine பண்ணும்போது I am getting it. Okay, I am getting it very big, not very big. Okay, it is going to be more than that of the mass of the nucleus. அப்படினா அங்க வந்து ஒரு mass defect இருக்கு. அப்படினா அந்த mass defect, அந்த massல இருக்கிற அந்த change தான், அந்த mass defect தான் எனர்ஜியா கன்வெர்ட் பண்ண போறோம். So whatever be the mass difference here, which means mass of the nucleons minus mass of the nucleus will be coming as delta m into c square பண்ணும்போது we will be getting binding energy. What is binding energy? Till this understood? Can you give me your favorite heart in the chat box, everybody? Till this understood? அப்படினா binding energy தான். I'm going to focus on binding energy. Binding energy சொல்லும்போது it is nothing but delta m c square தான். If this change in mass இல்லனா நம்ம delta m, if it is mentioned in terms of AMU, one atomic mass unit na, one atomic mass unit can give an energy of 931.5 mega electron volt. 2 AMU இருந்துச்சுனா இந்த ஒரு number into 2 you can find it. So இந்த மாதிரி delta m if it is given in what to say AMU, you can just simply go for the 931.5 mega electron volt into the AMU which you got. Got it understood, everybody? Yes, everybody, everybody tell me. This is what we need to study in the case of nama nuclei. So in the mass defect or equation one you should know, and also nama binding energy or expression one you know. Next one the nama fission and fusion da. So when I'm talking about stability, okay, when we are talking about the stability, okay, when we are talking about the stability, we know that in the binding energy per nucleon, okay, per nucleon சொல்லும்போது binding energy divided by mass number. So in the value வந்து high இருந்துச்சுன்னா we know that that will be stable. So now I am talking about which is less values, which means நம்ம mass number வந்து கம்மியா இருக்கிற small nuclei. And also I'm going to talk about the what is a bigger nuclei. Okay, bigger nuclei. So when I'm talking about this, when it comes to the lower mass number what is it, the nucleus pathena, it will combine, it will fuse together and will come to the stable state. That is what the process fusion. Okay, that is what the process fusion. And when it comes to higher nuclei, higher mass number இருக்கிற nuclei இல்லடா, அது வந்து combine பண்ணும்போது, what will happen da, what will happen, it will come to the, I mean it will just split and it will come to the stable state, and that process is known as the fission as well. So this is what fusion and this is what fission, and the properties வந்து I have given over here. Just try to understand நம்ம fission process ல வந்து there is a huge, I mean நம்ம fusion process, sunல இருக்கிறது fusion. Okay, so fusion process ல higher amount of energy வந்து release ஆயிருக்கு. Okay, higher amount of energy வந்து release ஆயிருக்கு. Radioactive waste வந்து கம்மி தான் நம்ம fusion processல. But when it comes to fission process, energy is released ஆனா வந்து it is not that much. Okay, and also when it comes to radioactive weight, it is actually more in case of fission. So you have to study these topics as well. Got it, everybody? Yes or no? Please let me know. And guys, marakama like panikoda. Everybody like the session quickly. Everybody. Okay. Yes, got it. So now can we go for the semiconductor? Ready? Yeah? Everybody is ready for the semiconductor? Ready now? Put some fire quickly. Everybody. Everybody, please respond. Ready? Yeah? Yes, perfect. So now we are going for the semiconductors. Okay, so just give me 2 minutes. I'll just come in 2 minutes. Okay, don't even go. I'm just coming in 2 minutes. Adikapram, we will be just continue with the semiconductors. Okay, just give me 2 minutes. So what is the time right now? 8:34. I will come by 8:37. Okay, because after saying all those things, I will take again some time. Right? Okay, so nama target irike like. So on the like target code, I'm just going for writing here. Okay. Okay, so this is what our target. And also, guys, one important thing is regarding the next, number final, the last, we will be just going to end this concept revision after finishing number semiconductors. Okay, so be ready for the semiconductor. Okay, so I'll be just come in 2 minutes. Okay, so see you. Break illada, just I need to take some water and I'll come. Hello guys, I promised you people, right? I will come sharp at 37 and I am here. Okay, so let us continue with the semiconductor. Ready, Ada? Everybody ready? Please let me know. Hey, why you guys are not responding? Quick call, let me know. Yes, perfect. So now we are going for the semiconductor part. So when it comes to semiconductor, thank you guys, Guys, don't forget to like the session, okay? We are going to end the session. Hardly 15 minutes, we are going to end the session. So I just wanted to make sure you people will be, those who are watching right now, they have liked the session. Okay, so semiconductors, first one, I will be going with the intrinsic semiconductor. Tell me what is intrinsic semiconductor. Intrinsic semiconductor na, it is nothing but pure semiconductor. இப்போ வந்து ஜெர்மேனியம்னா ஜெர்மேனியம் மட்டும்தான் இருக்கு. இப்போ வந்து சிலிக்கன்னா சிலிக்கன் மட்டும்தான் இருக்கு. So that is what the intrinsic semiconductor. So in the intrinsic semiconductor சொல்லும்போது அதுல வந்து conductivity, it is going to be less comparing with the extrinsic semiconductor. ஏனா வந்து அதுல வந்து we are producing this what to say, what to say? Yes, hi Nirmala. So right now, not Nirmala, I forgot your name again. Sorry. Okay, so now the thing is like nama intrinsic semiconductor la holes irukum, electrons irukum, free electrons irukum. Idoda number வந்து same தான். ஏனா வந்து we are producing this what is it, nama carriers, okay, nama what is it? Nama holes and free electrons வந்து we are producing by giving thermal energy. Heat வந்து we will give. And the heat energy கிடைக்கும் போது இந்த covalent bond will break. Okay, covalent bond will break. And the covalent bond break ஆகும்போது there will be a hole will be formed and also an electron will also be escaped. So same amount of free electrons and same amount of holes will be there in the what nama intrinsic semiconductor. Adanala it will be less when comparing with the extrinsic semiconductor. Idoda conductivity vande it is going to be less, and practical purpose ku kuda intrinsic semiconductor vande rare ah we will use. Ena vande we need more productivity illada. So adanala productivity increase agiradhukku we yes Dhanushya. Dhanushya, sorry da. Okay, so in the what to say, in the yes, in the conductivity is more in extrinsic. So practical purpose we will be using the extrinsic semiconductor da. Purinjiruchuna, can you give me a red velvet in the chat box quickly? So idukapran sollitena, we have the extrinsic semiconductor. Extrinsic semiconductor na, it is not going to be pure. Adula vande impurities irukum. Okay, adula vande two types irukku, p type irukku, n type irukku. So tell me what is p type, what is n type? P type சொல்லும் போது definitely அங்க வந்து பார்த்தேனா P positive holes தான் அதிகமா இருக்கும் comparing with the electrons. So majority charge carriers வந்து what to say, holes தான் in P type ல. When it comes to N type, அதுல வந்து majority charge carriers வந்து N negative na electrons, more வந்து electrons இருக்கும். So comparing with the number of electrons வந்து it is going to be more comparing with the holes in the case of N type. Understood? And right now the thing is like conductivity will be more in the case of what nama what is the extrinsic semiconductor da. And also when it comes to p-n junction, I'm just going to keep this p and n together. Okay, wow, P and N together. So definitely what will happen, initially inga irukra holes, inga irukra electrons will be get excited. Yena vande they can see their opposite polarity il irukra charge carriers. Okay, so adanala what will happen, inga irukra holes vande it will move towards the n side. In the n side la irukra electrons, what it will do, it will move towards the p side. So appadina inda oru flow nala there will be a current which is nothing but diffusion current. Very good, Fatima. It is nothing but the diffusion current. In the diffusion current, what is the reason for the diffusion current? It is due to the majority charge carriers. Majority charge carriers na P type la irukra N holes, N type la irukra electrons oda flow nala da in the diffusion current irukum. But definitely when time goes, what will happen da, in the P side la there will be a layer. Okay, there will be a layer in the P and junction vandu form agum, which means there will be a depletion layer will be formed. Anga வந்து பாத்தேனா இந்த holes and electrons will be coming as okay அவங்க வந்து immobile தான், it cannot move from there. So in the immobile layers of holes and electrons will be formed. So eventually what will happen, if the electrode is trying to come from here nalum inga வந்து electrons oda ஒரு layer da இருக்கு, it will stop this electron to cross this depletion layer. இப்போ வந்து holes will feel like okay yeah, let me go then. So then what will happen, in the holes will come from here. Definitely inga வந்து பாத்தேனா what is there, inga வந்து நம்ம holes oda ஒரு immobile layer இருக்கு. So definitely what will basically happen, in the flow will get stopped. So அந்த ஒரு டைம்ல பாத்தேனா இந்த p typeல I have mentioned you na majority charge carriers தான் இந்த இந்த holes. அப்படினா அங்க வந்து minority charge carriers இருக்கு. minority என்ன, p typeல இருக்கிற electrons, n typeல இருக்கிற holes. This will start flowing. Okay, அந்த minority charge carriersனால இருக்கிற இந்த flow தான் actually வந்து we will say it as drift current. So tell me what is diffusion current and drift current? Tell me the major difference between them. Everybody quick. So நம்ம diffusion current சொல்லும்போது it is basically due to the majority charge carriers da. Drift சொல்லும்போது it is majorly due to the minority charge carriers da. And when it comes to the depletion layer, அதோட width வந்து approximately 10 to the power minus 6 meter da. Okay, depletion layer oda width வந்து 10 to the power minus 6 meter da. In the diffusion current நால, yes, very good. Okay, yes. So இப்போ வந்து பாத்தேனா இந்த diffusion இந்த depletion layer form பண்ணதுனால அங்க வந்து electric field will form and that will be approximately 10 to the power 5 volt per meter da. So in the values வந்து you have to study. So now the thing is like we should understand when we are talking about this doping. Okay, doping na adding these impurities, நம்ம extrinsic semiconductor எல்லாமே வந்து we will be adding the impurities இல்லடா, அந்த ஒரு process தான் வந்து doping. So in the doping process when it comes to the doping process, if the doping increases, impurities வந்து added more, அப்ப வந்து what will happen, doping increase ஆச்சுனா நம்ம depletion layer ஓட width வந்து what will happen, it will be get reduced. Okay va? So next வந்து பாத்தேனா we are going for the forward bias and the reverse bias da. So tell me what is forward bias? Forward bias is very simple ma'am. When we have this PN junction illaya ma'am, in the PN junction la, in the P side la I will give the positive terminal of the battery, N side la I will be giving the negative terminal. What is this reverse bias? Just reverse this. P type la negative terminal, N type la வந்து positive terminal. So if you are doing this forward biasing, okay, when I'm doing this forward biasing, what are the advantages? Forward biasing நால நம்ம depletion layer ஓட width வந்து it will be get reduced. Okay வா? இந்த potential barrier ஓட what is in the depletion layer இல்ல அந்த potential barrier வந்து it will be get reduced. Okay va? And inga vandu paathena there will be a very small resistance only. Okay, inga vandu there will be a very small resistance will be there. Next vandu paathena you should understand about the knee voltage. Knee voltage na enna? We said no. When we were talking about this forward biasing, the majority charge carriers will go and depletion layer will be formed. So in the time at some point in the diffusion current will stop, right? Okay, which means ipo vandu germanium illena nama silicon vandu paathena definitely at some point in the current flow will stop. So இப்போ வந்து if I'm giving an external bias, which means இப்போ வந்து இந்த battery வந்து இந்த batteryல இந்த cellல I'm going to give the same voltage. Now what will happen? Again this depletion layer will become thin and this started this what to say நம்ம diffusion current will be again it will be formed. Okay va? So right now knee voltage for the germanium it will be 0.3 volt, for silicon it will be 0.7 volt. Now tell me what will happen in the reverse bias condition. What will happen to the reverse bias? Reverse bias illa definitely nama depletion layer oda width is going to increase only and there will be a high resistance. Okay, there will be high resistance. and இங்க வந்து பார்த்தேன்னா நம்ம current flow will be in terms of milliampere தான் அந்த range இருக்கும். But when it comes to the reverse bias, guys மறக்காம லைக் பண்ணுடா, இப்பவே வந்து லைக் பண்ணிக்கோ, because ஏன்னா வந்து இந்த வீடியோ will definitely help you in the future as well. So now high resistance தான் இங்க வர போறோம். And also I can say that இங்க கூட when we are giving, okay, I'm just increasing. Yes, exactly Maha. Yes, இதுல வந்து current ஓட flow னா இது வந்து மைக்ரோ ஆம்பியர்ல தான் இருக்கும். Okay, reverse biasல minority charge carriersனால மட்டும்தான் current flow இருக்கும். Okay, அது வந்து மைக்ரோ ஆம்பியர்ல தான் இருக்கும். Next வந்து பார்த்தேனா we know that we are giving the potential increasing. At some point this will get damaged. Okay, this will be get damaged. Damage ஆகிற அந்த particular potential da breakdown voltage. Okay, breakdown voltage. So இது வந்து பார்த்தேன்னா நம்ம ஜெர்மேனியத்துக்கு வந்து 25 வோல்ட் தான், and நம்ம சிலிக்கனுக்கு வந்து 35 வோல்ட் தான். So breakdown voltage னா என்ன? At some point it will be get damaged. அந்த particular voltage தான் breakdown voltage. For germanium 25, for silicon it will be 35. Understood everybody? Give your favorite heart. Give your favorite heart immediately. Thank you Hajar. Thank you. Guys மறக்காம லைக் பண்ணிக்கோட everybody. Everyone should like the session. So now we are going to study about this. What is a PN junction diode is done. Now rectifiers is there. Okay, rectifiers சொல்லும்போது பேசிக்கா வந்து we are using it for converting AC to DC தான். கரெக்டா? We are going to convert AC to DC. So இந்த ஒரு டைம்ல பார்த்தேனா, okay, இப்போ வந்து half wave rectifier சொல்லும்போது half wave rectifier சொல்லும்போது it is nothing but we will be giving an input like this and we will be getting an output like this. Okay, so now the thing is like the input frequency and the output frequency for the half wave rectifier it will be same, and efficiency சொல்லும்போது it will be coming as 40.6%. When it comes to the full wave rectifier, okay, full wave rectifier சொல்லும்போது we can say that the input வந்து இப்படி தான் இருக்கு. Okay, full wave rectifier சொல்லும்போது input வந்து இப்படி தான் இருக்கு, output will be coming like this. இதுதான் வந்து நம்ம full wave. Yes Dajia, what to do? Okay, so anyway we are going to end. No, okay, we are going to end. Okay, so now எனக்கு வந்து எப்படியாவது இது வந்து finish பண்ணணும்டா. I was expected I could at least finish in 2 hours 15 minutes. Now it is almost going to be 2.5 hours. Correcta? So that is what making me little bit stressed. Okay, so இந்த வந்து நம்ம full wave rectifier பார்த்தேனா நம்ம input frequency விட 2 times தான் நம்ம output frequency, and நம்ம efficiency வந்து it will be coming around 80%. Okay, so this is what the important thing that we have to notice in the case of half wave and full wave rectifier. And in the full wave rectifier we will be using center tapped transformer. ஏனா வந்து we need to switch the, okay, இப்போ வந்து negative cycle வந்து we need to make it to 180 degree switch, which means positive cycle இருக்கணும். Okay, positive cycle வரும்போது we should go for the negative cycle. So அந்த switchக்காக தான் actually வந்து we are using the step நம்ம center tapped transformer. So this is what we need to study in the what is நம்ம rectifiers. Next வந்து நம்ம special purposes PN junction diodes தான். First வந்து Zener diode சொல்லும்போது அது வந்து reverse biasல தான் it is acting, and also it won't be get damaged ஏனா வந்து அது it is actually heavily doped தான், and we will be using the Zener diode as the voltage regulator. ஏனா வந்து always if we are connecting a Zener diode across any device we will cover Fatima, we will cover logic gates the kapra. Okay, so any device oda parallel if you are connecting the Zener diode na, and the Zener diode oda voltage exactly it will be get it for this object. Okay, and the device ke exactly and the Zener diode whatever be the voltage varying in the circuit never matter, it will be always going to be constant. Okay, and the Zener diode oda voltage da and the device ke eppovume kadakka porum. Next one the photodiode da, photodiode is also working in the reverse bias condition. Okay, reverse bias condition la da it is actually working. So actually சொல்லும்போது இந்த photodiode is actually converting. Okay, and the light வந்து okay it will be converting. நம்ம light will fall on the photodiode, it will convert into electric signals. இதுதான் வந்து photodiode la it is actually happening in the reverse bias condition. The light, when light falls, electron hole pair will be formed, and that is what the process which is happening in the photodiode. Now the thing is like we we have the light emitting diode. Light emitting diode na adu vandu forward bias la da it is actually happening. And here what is happening in the light emitting diode, light will emitted in the form of photons. So photons vandu depending upon the energy, depending upon the wavelength, depending upon the frequency, it will be releasing different kind of what to say colors. So light emitting diode, which is actually working on the forward bias condition, and electrons from the n side recombine with the holes, and over time it will release some energy. Okay, நம்ம recombination process la it will release some energy in the form of photons, and the photon oda energy is, we know that adoda equation vandu hc by lambda da, it is depending upon the wavelength. So on the wavelength depend panni it will show different colors. Solar cell na adukku vandu we are not going to give any kind of biasing, there is no biasing. It will actually in the light vandu it will convert as a EMF. So idu vandu actually vandu light energy will convert into electrical energy. This is what the solar cell. Zener is in reverse, and also LED is in forward bias. Okay, so now nama logic gates da ready ada, logic gates, everybody ready? Give me some fire quickly if you are ready for the logic gates. Everybody and guys marakama like panikoda. You didn't like the session till now. I can see here those who are watching right now avanga vande like pannala, I have seen that. Okay, yes, ready. Okay, நம்ம last topic da. Okay, நம்ம இந்த ஒரு 3 hour session la last topic da. Okay, so right now logic gates da. First vandu you should understand what is the NOT gate. Color vandu visible allada? Yes, NOT gate da. So very simple, NOT gate சொல்லும்போது அதுக்கு வந்து there is only one input. Okay, இப்போ வந்து இது வந்து A na, this will be A bar. So you can give inputs as 0 or 1. Okay, இது வந்து binary இல்ல. So 0 or 1 மட்டும்தான் we can just go for it. So 0 will be coming as 0 note na, அதுக்கு வந்து it will be coming as 1, and 1 na அதோட note வந்து 0 தான். புரிஞ்சுதாடா everybody? Yes or no? So right now I am going for the OR gate. Okay, I am going for the OR gate da. OR gate na very simple, y is equal to a plus b. Very simple. So ipo vandu paathena nama OR gate oda construction, this is how we will be representing the OR gate. idukku vandu two inputs irukum, a b. So now I'm just going to show you the combinations, and you have to tell me what will be the y. Okay, so here 0 0 can be happen, 1 1 0 1 and 1 0. So what will be the y? Everybody tell me. So 0 0 varumbodhu 0 plus 0 it will be 0. 1 plus 1 it will be, the maximum value is 1. Even if we know that 1 plus 1 2 illa ma'am, then why here? Because we have only 0 and 1, higher and lower. So 0 plus 1 it will be 1. 1 plus 0 it will be 1. So this is what the OR gate. Now I'm just going to discuss about the NOR gate. NOR gate na very simple da. It is actually the combination of OR plus NOT da. Which means nama OR gate inga irukke. Okay, whatever be the result we are getting from this OR gate, okay, adu vandu we will go for the NOT of it, which means a plus b NOT it will come. So can you just give me what is going to be the result of this one? What is going to be y dash? Very simple, it will be coming as inga vandu y we got it as 0, a plus b vandu 0 da, adoda NOT da vandu NOR gate la irukum. So this will be 1, this will be 0, this will be 0, this will be 0. If you guys understood, can you give me a red velvet in the chat box quickly? Can you give me a red velvet in the chat box quickly, everybody? And guys, don't forget to like the session. Do not forget to like the session, everybody. Yes. Got it? So now can we go for the AND gate? Very good. So AND gate சொல்லும்போது multiplication da, which means y is equal to a into b. So which means we can just say, okay, இந்த மாதிரி தான் இதோட construction வர போறோம். So a b we can just give. So again we can just try for the combinations. Okay, 0 0 1 1 0 1 1 0. Okay, so this is what the combinations. What will happen? 0 into 0 0, 1 into 1 1, 0 into 1 0, 1 into 0 0. So next one the nama NAND gate da. So NAND gate சொல்லும்போது again AND gate we will add a NOT of it. So this is what the NAND gate. NAND gate na very simple, it is nothing but y bar. What is y bar? Inga vandu what you got it, a dot b illa adoda note. So tell me what is going to be நம்ம NAND gate oda result என்னடா? Can you give me the answers quickly? Guys மறக்காம லைக் பண்ணிக்கோ. 0 இங்க வந்து 0 தான். அதோட நோட் வந்து it will be 1. இங்க வந்து 1 தான். So it will be coming as 0. இங்க வந்து 0 1 1 it will come. Understood? Can you give me a green forest quickly in the chat box everybody? And guys, don't forget to like the session. மறக்காம லைக் பண்ணிக்கோ. Everyone should like the session quicker. Everybody like the session quickly. Yes, perfect. So appadina now you have to understand some of the results as well. A plus A bar. A plus A bar na enna 1. இப்போ வந்து A வந்து 1 தான். appadina A bar என்னடா 0. So A plus A bar. So which means 1 plus 0 will be 1. So next one I can give A is equal to 0 and A bar will be coming as 1. Again I'm doing A plus A bar. What I will be getting? 0 plus 1, it will be 1. So can I just make a statement that A plus A bar will be always 1? Can I say that? 9 more likes, guys. You can. Those who are watching, you can just, subscribe the channel, plus you can like the session. So A plus A bar, it will be coming as always 1. Okay va? Next result enna? A dot A bar. Okay. இப்போ வந்து A வந்து 0 na A bar will be 1. 0 into 1, it will be always 0. Okay. Even if we are taking A as 0 also, in the result வந்து it will be coming as 0. Next one, the A plus A dot B. So now I'm just going to do one thing. I'm just taking A outside. So what I will be having in the bracket, I will be getting 1 plus B. Correct? Which will be coming as A. Yena வந்து 1 plus B na, it will be always 1. Okay, 1 plus B na, just imagine, B வந்து 0 ஆகலாம் 1 ஆகலாம். Correct? So now I can say that A into 1 plus 0, or otherwise it will be A into 1 plus 1. What is the result? It will be A into 1 da, so this will be A. This is also going to be A. So I can say that A plus A dot B will be A. Another one is A plus A dot B will be A plus B. So these results are very, very important. You have to understand these concepts as well. Next important thing enna nama De Morgan's theorem da. So you guys have to study this. A plus B the whole bar will be coming as A dot B. Okay va? A plus B the whole bar, which means we can see here idu vandu NOR gate da. NOR gate oda result enna? We will be getting A bar plus B bar. Purinjada da? A plus B the whole bar, which is nothing but A bar dot B bar da. Next one, smash the like button, guys. We are almost reached our second target. Okay. So A dot B bar solumbodhu A bar plus B bar it will come. So you have to study this De Morgan's theorem as well, which is very, very important, and try to understand number NOR gate and NAND gate is known as the universal gates. Okay, universal gate da. Why it is mentioned as universal gate? Why it is mentioned as universal gate? ஏனா வந்து அந்த 2 gates மட்டும் போதும். You can make all the rest of the gates. That's why it is known as the universal gates. Understood everybody? Can you please let me know? And also let me just introduce நம்ம free Re-NEET crash course. இப்போ வந்து நம்ம what is in the description box la second link la you can see the free Re-NEET crash course. Idhula vandu you can just go for go. Okay, nama zero price la 4999 oda course vanda you are going to get it for zero price. Okay, so you can just go for buy now. So in the buy now pannitena, definitely you are going to get our course. So physics, chemistry, biology classes, nama test will be there, and also nama doubt solving 24/7 instant doubt solving will also be there. Okay va? So next வந்து பாத்தேனா நம்ம description boxல இருக்கிற first link. Okay, இது வந்து new da. How many of you have already filled the sheet? How many of you have already filled the sheet for this mock test? Please let me know with a red heart. So in the நம்ம mock test க்கு வந்து நம்ம first link வந்து click பண்ணலாம். அப்படினா you can see 13th June க்கு வந்து from 2 o'clock to 5 o'clock you can attend this exam from any of your you know that நம்ம வேதாந்து center வந்து there are in many places. So you can just take any of the place which is close to you and you can go for the exam, and after that you can go for submit. Definitely you will be getting a call and you can just I'm there in the VLC Re-NEET crash course, ma'am, so I didn't register. Okay, Fatima. Okay. Fine. Got it. Yes, Hepsi. Ba. How are you? Okay, so this is what the things we need to discuss in the class. So I think almost 3 hours, right? Okay, இன்னைக்கு வந்து 3 hours we have done with the volume 2. Okay, so அதுல வந்து 15-20 minutes வந்து break ஆயிருந்துச்சு, but definitely we have finished it and I hope it was useful. Maybe in the last 6 more likes, guys, those who are watching, you can like the session right now. Okay, நம்ம target achieve பண்ணலாம்ல. So right now the thing is like இப்போ வந்து இந்த ஒரு session volume 1 and 2 வந்து volume 1 ஓட what is a link வந்து நம்ம comment sorry நம்ம chat boxல இருக்கு. ஓகே, நம்ம chat boxல இருக்கு. அந்த chat boxல இருந்து அந்த link வந்து click பண்ணிட்டேனா you can watch the first part as well. அது வந்து we have done, I think we have done in 3 hours volume 1 and இது வந்து almost 2.5 hours ல, okay, almost 3 hours ல we have done with this also. I hope this was really helpful. ஏனா வந்து எக்ஸாம்க்கு வந்து இன்னும் கொஞ்சம் டேஸ் தான் இருக்கு. கான்செப்ட் ரிவிஷன் அவ்ளோ டிஃபிகல்ட் தான். ஓகே, sitting for a long time to study this and especially this is physics, irritating ஆ இருக்கும். Okay, so I think I have cleared all your what is a concept related ஆன doubts எல்லாமே வந்து I think we have done everything. So I just wanted to make sure you people will be revising properly. In the notes எல்லாமே வந்து I will be updating in the what is a comment box as well. In the session முடிஞ்சதுக்கு அப்புறம் you can just access it and you can just go through it. This will be going to be very much helpful. நம்ம last 2 days இல்லையாடா நம்ம 48 hours அந்த 48 hours ல just watch these videos which is going to be helpful. ஏனா வந்து we should remember everything இல்லையாடா. So அதனால தான் I'm telling you, please everybody do try to watch this session on the last day as well, because physics at least if you know the concept, I am telling you easy questions are there. Okay, easy questions are there. So please guys, everyone should remember about that and I wanted to make sure you people will be doing it. And how was the class today? Can you please let me know? How was the class today? Many people have cheated me, but still, how was the class? Tell me. Okay, we need few more likes to achieve our target. Okay. Yes. Oh my god. Chat போயிட்டேன்டா. Why it is not coming? Why the chat is not coming for me? Yes, done. Yes, class was amazing. So இப்போ வந்து நம்ம what to say in the comment boxல கூட I just wanted to see the same spirit. ஏனா வந்து again last few daysல many students were looking for this what is a precise ஆன concept revision. So அவங்களுக்கு கூட I mean it will be a motivation if you people are giving a feedback about this class. So மறக்காம இந்த session முடிஞ்சதுக்கு அப்புறம் you should give me a feedback regarding this class which is going to helpful for the others. Yes, I really like the session and I realized that I remember those formulas. Thank you ma'am. Okay Ashika. Ma'am, next class la Gates diagram explain. Gates diagram வந்து we have explained no da. What is that yoga? Okay, tell me others. You make us to like physics, ma'am. Thank you, Divya. Thank you. Okay, ma'am. We will help with the... Yes, exactly, Fatima. Exactly. Jia, I'm skipping this question. Sometimes you will skip the physics questions, right? So, on the Madri, I'm skipping this question for right now. Okay, let me see. Okay, da. So, thank you so much. I see my mark 665 mock test. Very good, Hajar. Very good, very good. Ma'am, class, physics class. Ma'am, class, physics class. Okay, Ashika, thank you so much, da. Thank you so much. So, guys, Marakama feedback. Okay, I wanted to see the comment as well. And also, I think I got a little bit of more energy from the session. Thank you so much. Thank you. Bye-bye. See you. Yes. Hajar, very good, da. Very good, very good. Super, super. I could understand clearly. Okay, sorry, sure. I again after the live. Okay, da. Okay. So, see you guys. Thank you so much.